Hello, good morning everyone. In the last class, we talked a little bit about history of astronomy. We also discussed some of the basic ideas before we could jump into space technology. And we had started our discussion about types of orbits. So if you have any questions from whatever we discussed in the last class, you can ask questions. Sorry? Amplify. Amplify का मतलब होता है किसी चीज के मैग्नीट्यूड को इंक्रीज करना. हाँ, तो मैग्नीट्यूड होता है किसी चीज को मेजर करते हैं, किसी यूनिट में मेजर करेंगे. जैसे इस माउस का मास है 200 ग्राम है मान लो. सो ये इसका मास का मैग्नीट्यूड हो गया. मैग्नीट्यूड इज सिंपली आई एम मेजरिंग समथिंग इन सम यूनिट. इट कैन बी एनीथिंग. माई हाइट, that is my height's magnitude. So magnitude is simply measuring something in some unit. Amplifying means increasing some parameter. Often it is used in case of energy of waves. So in science, when we use the word amplification or amplify, then we often mean in the context of amplifying some energy. For example, I'm using this mic here, which is amplifying my voice so that it can reach to the back of the class. What was the third word you asked? Okay, momentum is mass times velocity, a parameter again we use in physics. And to appreciate momentum, think about a bus traveling with, let's say, 20 kilometer per hour and a car traveling with, let's say, 40 kilometer per hour. And there is an accident because of a bus and because of a car. Bus is going to cause more damage. Even though it was half of the speed, its total mass will be more than half of the car. So the parameter mass times velocity, that parameter we use, that parameter is called momentum. And why we use this word momentum? Because turns out that for our discussion, momentum is a much more fundamental parameter. But for our discussion, momentum basically meant that rate of change in momentum is force as per Newton's second law of motion. Any other question if you have? Sorry? Of course it does. I told you in this. The question is that does sun revolve? Of course sun revolves. Sun revolves around the center of Milky Way galaxy. Any other question? Okay, now that's a good question. The question is that what is the difference between mass and weight? Mass literally is the magnitude of matter, or think of all of the matter. And I'm measuring that matter in a unit called kilogram. We often use these two words interchangeably a lot. Mass and weight जो है, जैसे if I ask you what is your weight, you're going to say 60, 70, whatever. You're not going to say Newton, but weight actually is a force. So weight का जो actual unit है वो Newton है. And why we use these two words interchangeably? Because fundamentally, the weight you feel, that depends upon your mass, right? Sorry. That आपका जो भी weight है, that depends upon your mass, and that small quantity which you see g, that is called acceleration due to gravity. On the surface of Earth, more or less, its value will be 9.8 meter per second square. But because your weight depends upon your mass, we often use these two words interchangeably because most of us are going to be on Earth only. But let's say if you do get to go on, let's say moon, then on moon, what about your mass? Your mass does not change. Nothing happens to your mass. Whatever your mass is, that remains the same. But moon is a much smaller object, and moon पे जो आपका weight है, that is going to reduce, right? So moon पे आप long jump ज़्यादा कर पाओगे, high jump ज़्यादा कर पाओगे. Moon is a smaller object. जो gravitational pull है moon का, वो कम है. तो वहाँ पे जो आपका weight होगा वो कम हो जाएगा. Sun के case में, if you can survive, let's say on sun, then your weight is going to increase. But mass always will remain the same. Mass is amount of matter which you have inside your body, or for that matter, for any object, the amount of matter, we measure that into kilogram. Weight we measure because multiply that mass with acceleration. Remember, this is mass and g is acceleration, and mass times acceleration we just discussed in the last class is nothing but force. So think about it, weight का जो unit है वो Newton है. The same way force का unit जो Newton है, and weight is a vector quantity. because weight is a force, so it is a vector quantity, but mass is a scalar quantity. So there are many differences between the term mass and weight. The reason we use them interchangeably, because simply on Earth, of course, your weight depends upon mass, and that is why we choose these two words interchangeably. I haven't talked about geostationary or geosynchronous. I will talk about that. In fact, that will be my very first or second topic in today's class. Yes. So geostationary, geosynchronous, I'm going to discuss in detail in today's class. ओके, कार्बन लाइन एक इंपॉर्टेंट चीज है, ये पता होना चाहिए. आप साइड में कहीं पे लिख भी सकते हो. बट मान लो ये अर्थ है. So I use the word space a lot, but remember in the last class I told you that we should be very clear about definitions we use. So when I use the word space, how do I define space? Like, is there some height above that I can call it space? Turns out that this height is not fixed. It essentially depends upon at a height where you can attain an orbit, stable orbit, you can feel weightlessness. And it frankly depends upon how atmosphere thick is. And turns out atmosphere का जो thickness है वो सारे latitude पे same नहीं है. Atmosphere का जो thickness है वो equator पे अलग है, pole पे अलग है. So technically the definition of space will vary from places to places. But so that all of us are on the same page, there are certain think tanks which define space as this imaginary line 100 kilometer above surface. So anything above 100 kilometer, we call it space, and this imaginary line is called Kármán line. I will repeat, Kármán line का कोई scientific logic नहीं है. ये हम सिर्फ इसलिए use कर रहे हैं that all of us are on the same parameter when we use the word space. What do I mean by the word space? So some think tanks, they do use this term, and this has become quite popular. Many people now use this concept of Kármán line. Yes. Generally, when we use the word outer space, we are basically talking about place where you can find a stable orbit, you can feel weightlessness. And in some cases, outer space often is used for once you cross, let's say, you do find a stable orbit. So not as any difference. So outer space is a term which can be interchangeably used with space. This term particularly has a specific utility in a treaty, a global treaty, which is called Outer Space Treaty. So Earth के around जो भी पूरा space है उसको अलग-अलग countries कैसे use करें. But ऐसे we can use them interchangeably. Any other question if you have? How can a weight be force when the acceleration is zero? There can be places where acceleration will be zero, and in that case weight हमेशा ही force है. The only thing is that उसका value zero होगा. जैसे if there is a lift and it is falling down, you're not going to feel any weight. When you travel in a spacecraft, you're not going to feel any weight. So your weight is zero, but that does not mean that weight is not a force. It simply means that force is zero. That force of attraction, you do not feel that force of attraction. Any? क्वेश्चन ये है कि हम अर्थ के अराउंड अगर एक सैटेलाइट है तो हम उसके स्पीड को बढ़ा घटा या रोक सकते हैं. वैसे तो हम कर सकते हैं, बट आइडियली हमारा गोल यही है दैट सब कुछ हम ग्रेविटी के कारण करें. हमारा फंडामेंटल ऑब्जेक्टिव ये है दैट लेट्स यूज ग्रेविटी सो दैट इट कैन अटेन अ स्टेबल ऑर्बिट. वंस वी लॉन्च अ सैटेलाइट इनटू इट्स ऑर्बिट, then its movement is guided by Earth's gravity. It does not require a fuel per se. We do use some fuel in some cases if we have to make some emergency adjustment, some changes here and there. So we do carry some amount of fuel. From time to time we can use it, and we can change its orbit, or if you want we can increase or decrease the velocity. But nonetheless, our goal here is that we should not be requiring to do that. हमको जरूरत नहीं पड़नी चाहिए. Everything will be done by Earth's gravitational force. So technically the answer to your question is yes, we can, but ideally we would not want. We would want to do that as less as possible. That जरूरत ना पड़े. सब कुछ Earth का gravity जो है उसके कारण हो. जो fuel का consumption है वो rocket में है. Once you launch a rocket, launch a satellite into a stable orbit, rocket falls down on the Earth, burns up in the atmosphere. After that, there is a satellite, and that's it. That satellite is now moving around Earth, not because of fuel, but because of Earth's gravitational pull. it has the required centripetal force where you can find a stable orbit. We discussed that in the last class. In today's class, I will continue the discussion where we left in the last class. We're talking about types of orbits. Before I come to the last type of orbit, there is a small criteria which we should know. Based on shape, two shapes are possible. Circular, there are very few orbits which are circular. Just there is a very special orbit called geostationary orbit which is circular, and many polar orbits are also circular. But most of the orbits are elliptical. Most of the orbits. However, जो elliptical orbits है, जैसे मान लो ये अर्थ है, so they are not this ellipse. They are more like this ellipse. So जो elliptical orbits होंगे, they will be closer to circle compared to an elongated orbit. So this will be a more realistic scenario compared to this one. So technically, most of the orbits are elliptical, but they are closer to circle. The difference between perigee and apogee will not be very high. There are some special orbits where it is high. I'm going to talk about that also in today's class itself. So this is also a criteria we should know of, that most of the orbits are elliptical, but there are some special orbits. One of them is very famous orbit, which is my next topic, geostationary orbit. But criteria 4 is a very special classification. अभी तक जो हमने 3 classification किए हैं, these are general classifications. General का मतलब ये है that an orbit will be either LEO, MEO or HEO. An orbit will be either polar, equatorial or inclined. An orbit will be either circular or elliptical. But the last criteria which I'm going to use, I'm going to talk about 2 types of orbits, geosynchronous orbit and sun-synchronous orbit. But it should be very clear that it's not either or situation. Both of them are very special orbits, but apart from both of them, there are thousands of other types of orbits which exist. But these 2 orbits, geosynchronous and sun-synchronous, they're quite special orbits. So my criteria 4 here is based on Earth's motion. And Earth has 2 types of motion. Earth rotates on its axis. If there is an orbit which is synchronized to this rotation, this orbit is called geosynchronous. And Earth revolves around Sun. If you have an orbit which maintains orientation with respect to Sun, it is called sun-synchronous orbit. Both of these orbits are very special orbit with their own unique set of utility. So give the first heading, geosynchronous orbit. जियो का मतलब अर्थ होता है, synchronous का मतलब we are talking about some sort of synchronization with Earth. In this particular case, we are talking about synchronization of satellites' orbital revolution with Earth's rotation on its axis. So Earth rotates on its axis in 24 hours. In fact, it is not exactly 24 hours. It is less than 24 hours. Earth rotates on its axis in 23 hours, 56 minutes, and 4 seconds. This particular time is called sidereal day. I am going to approximate that to be 24 hours. So I will be using 24 hour from now onwards. But just to briefly tell you that when I am using the word sidereal day, it is about 4 minutes less than 24 hour. Why not 24 hour? Why less than 24 hour? Why 4 minutes less than 24 hour? जैसे जो 24 आवर का जो क्लासिफिकेशन है वो तो हमारे हाथ में था, तो हम इसको 24 आवर बोल देते, 23 आवर 56 मिनट 4 सेकेंड को। ये 4 मिनट कम करके हम क्यों बोल रहे हैं साइड रियल डे? Does anyone know the answer to this question? Remember, time classification, it is in our hand. We could have defined this time as 24 hours, right? But we did not. We do not define this time as 24 hour. We define 24 hour, and then we say that Earth does not complete one rotation in 24 hour, but in 23 hour 56 minute 4 second. If you do not know, then this is your homework. Go and search about it. That जो sidereal day है, it's a very simple question. I want you to do some, खुद से भी थोड़ा search करना सीखो. How do we find knowledge all by ourselves also? And answer this question in the next class. I will ask the same question in the next class. If you still do not have the answer, of course I will answer it. But I do think you will find the answer. So I have a homework here for you. You have to do a very simple thing. You have to go and do a simple Google search that why sidereal day is 4 minutes less than 24 hour. Why not exactly 24 hour? Anyways, that's a separate question. Geosynchronous orbit का मतलब बहुत simple है, that we want a satellite to be launched into an orbit जहाँ पे जो time period of revolution है, the time period of revolution is exactly the Earth's rotation, which is 24 hour basically. I'm going to use 24 hour from now onwards. So if a satellite revolves in its orbit in 24 hour, then we call this orbit as geosynchronous orbit. Very simple definition. But why this is such a special classification? What is so big deal about it? And big deal को समझने के लिए we have to go into a very special type of geosynchronous orbit, which we call geostationary orbit. So again I will repeat that satellite का जो revolution period है, एक complete revolution, वो 24 घंटे में है. I told you in the last class that if a satellite is launched into, let's say, 600 kilometers, it is going to revolve in about 100 to 120 minutes. So clearly, if the time period is 24 hours, the height has to increase. I told you the time period of revolution only and only depends upon how far you are from Earth. It does not depend upon your mass. तो अगर आपका time period 24 hours है, तो आपका height बहुत ज़्यादा होगा. And it's not a very difficult mathematical calculation, but we do not have to do it here. The answer is that if I know my time period of revolution to be 24 hours, then I know that my height from the Earth's surface comes out to be 35,786 kilometers. So I told you in the last class that there is a very 200 से 2000 बहुत special, वो तो round off figure लग रहा था, but this is a very precise value, 35,786 kilometers. So why this precise value? The reason is very simple, that 35,786 kilometers at this height, a satellite revolves around Earth in 24 hours. But what is so big deal about it? So to understand the big deal, we have to go into a very special type of geosynchronous orbit. Now I can attain geosynchronous orbit at any inclination. I can have a geosynchronous orbit at 50 degree or 140 degree. But I want you to focus upon the geostationary, which is 0 degree. So I am trying to now explain the equatorial geosynchronous orbit. And that equatorial geosynchronous orbit we call geostationary. Now what it will look like? First, let me explain then this in 2D. Then I will explain that in 3D. And then of course I will show you an animation also that what it will look like. But आप इसको ऐसे समझो. So for example, think about, this is equator. And there is a satellite just above equator. Equatorial orbit का क्या मतलब होता है कि जो equatorial plane है उसी के ऊपर हमारा satellite है. And think about a point on this equator, that this satellite is above this particular point here. And one rotation basically means 360 degree, but one revolution also means 360 degree. What it means is that satellite का जो revolution angular velocity है and जो earth का rotation angular velocity है, दोनों exactly same है. So when this point rotates and comes here, the satellite is also going to revolve and will be here. When it reaches here, the satellite will be here, and you get the idea. So it will seem like that this satellite is always above this particular point. Equator पे एक point है, and it will seem like that this satellite is fixed just above this particular point on equator. So hence the word geostationary. Geo means earth, that with respect to earth it will seem to be stationary. So again, now let me explain that in 3D. So think of that at the top of this pen I have a satellite. That this pen, this height here is, let's say, 35,786 kilometer, and the top of the pen is a satellite. And because both of them are rotating and revolving at the same angular speed, if there is a point on equator, and if both of them, ये rotation है Earth का और ये revolution है satellite का, so it will seem like that this particular satellite is always above this particular point on Earth. So why that is a big deal? Because now think about that there is a satellite here, and I have a radio station anywhere in this part of the Earth. So even if Earth rotates and satellite revolves, I do not have to worry about that my synchronization will be lost. I will always be able to look at the satellite in the sky. I will always be able to send signal to the satellite in the sky, and that satellite will broadcast that signal back to Earth. This is very useful for communication satellites. Remember I told you, for communication, I need synchronization. If I have a radio station here and satellite here, then it does not make a lot of sense, because I will not be able to establish a communication channel. So in this case, anywhere on this part of Earth, if I have a radio station, I will be able to send a signal to this particular satellite. But this is also quite useful for spy satellites, or in general for Earth observation satellite. That America, for example, has launched a spy satellite. No country will accept it, by the way. It should be very clear. No country will say that I have a spy satellite. फिर spy का मतलब क्या हो गया? If everybody knows you are a spy, then you are not a spy. James Bond is the worst spy. Anyways, so this particular satellite here can look at this particular part of Earth all the time as Earth rotates and satellite revolves into its orbit. So geostationary orbit is very, very useful for communication, but it also has applications in Earth observation. Now I can go back to geosynchronous. What will geosynchronous be? Now, geosynchronous does not have to be 0 degree. It can be 0 degree, but it can also be some other inclination. So imagine that I have a satellite whose inclination is, let's say, 30 degree. So as this, let's say at this point of time, satellite is here and it revolves around Earth as Earth rotates. So let's say, for example, for a point here on India, the satellite will seem like it is going up in the sky. And then after point of time, it will seem like it will come down in the sky. But for most of the time, still this satellite will be able to maintain synchronization with any radio station which is in India. If it is very inclined, let's say 80 degree, or let's say 140 degree, then there will be a case where we will lose the synchronization. But still we will be able to maintain that synchronization out of 24 hours, still for let's say 8, 9, 10 hours, minimum 8, 9, 10 hours. And जितना कम inclination होगा, हमारा synchronization उतना ज़्यादा होगा. Geostationary में I maintain that synchronization 24 hours. So now think about, if I want to establish a proper communication channel all across Earth, I need to perhaps launch 2 geostationary satellites. एक यहाँ पे, एक यहाँ पे, and I have, ये दोनों एक दूसरे से connected है, and now these 2 satellites can receive signal from almost 80 to 90% of Earth. They will only not be able to receive signal, let's say, from polar areas. But for most of the Earth, this part of the Earth and this part of the Earth, they will be able to receive signal just with 2 satellites. And if I add one more geosynchronous, I can cover all of the Earth. So the beauty of geosynchronous and geostationary orbits are that with minimum number of satellites, I can create a 24/7 communication channel anywhere on the Earth. Again, it's an amazing coincidence that Earth rotates so fast. It rotates 24 hours on its axis. There are very few planets which rotate faster than Earth. Jupiter rotates faster than Earth, but most of the planets, they rotate actually quite slow. So it's quite useful for us. This rotation is quite useful for us, that we can launch satellites for different type of purposes. So geosynchronous, any inclination, 30, 40, 50, including 0. But if it is 0, this particular orbit is called geostationary orbit, right? So geostationary is a very special case of geosynchronous orbit. So first give this heading geosynchronous orbit and write down few things here. Satellite in geosynchronous orbit. Satellite in geosynchronous orbit completes one revolution in exactly the same time Earth rotates on its axis. Earth rotates on its axis. In bracket you can mention side real day, one side real day, 23 hour 56 minute 4 seconds. Do not have to remember the exact figure, just remember that it is less than 24 hour. Such orbits lie at the height of 35,786 kilometer. 35,786 kilometer. A very special case of geosynchronous. Geosynchronous is geostationary orbit, which is a circular equatorial orbit, a satellite in geostationary seem to be fixed with respect to a point on equator. These orbits are very useful. For communication satellites, but also utilized for remote sensing satellites or navigational satellites. Also utilized for remote sensing satellites or navigational satellites. अब जैसे एक चीज बहुत क्लियर होना चाहिए, the geostationary एक ही ऑर्बिट है. There is only one orbit which is an equatorial orbit at the height of 35,786 kilometer, and it should be very clear that it is a very crowded orbit, right? ये बहुत crowded है, इतने सारे countries हैं, सबके अपने satellite है, so it's an extremely crowded orbit. All of these satellites are different point and they are rotating as Earth rotates on its axis from west to east. So they have to maintain that same synchronization, all of them moving in the same direction, west to east, so that they do not want to collide, of course. So we launch all of those satellites in the same direction. It's a very crowded orbit. In fact, it's so crowded that there is a global body which regulates launches into this satellite. This global body is called International Telecommunication Union, which is an agency of United Nations. I will be talking about this body in more detail in ICT classes. It does a lot of things with respect to communication, including this, launching into geosynchronous and geostationary orbit, that you need some sort of permission from them, or you need a regulatory approval from International Telecommunication Union before such launches. So what these orbits will look like, I have a animation here which I can show. So as I said earlier, that geostationary is a very specific case of geosynchronous orbit, which is equatorial orbit. The satellite here revolves in the equatorial plane at the height of 35,786 kilometers, including this, but all other orbits. But the prerequisite is the time period of revolution should be 24 hours. We call all of those orbits as geosynchronous, right? So geosynchronous are many orbits. Geostationary is only one orbit. It is a very special case of geosynchronous orbit, which is also equatorial orbit. Now, what all of these orbits will look like in 3 dimensions, there is a very good YouTube video which I can show you here. From time to time, I will be showing some YouTube videos, but I will also recommend you that go and watch these videos, and I would expect that you do actually go and watch this video instead of watching reels on your mobile phone. So yeah, I'm speaking like an uncle now, right? So watching reels. So an equatorial orbit will look something like this. Think of a satellite, and that satellite, as Earth rotates, the satellite revolves exactly with the same rotational speed, angular speed, and it will seem like that this satellite is fixed with respect to a particular point on Earth. And the utility of this particular orbit then will be that a satellite in this orbit will maintain synchronization with the part of Earth it is facing all the time. We do not have to worry about that this synchronization will be lost. Polar orbits, which I was talking about in the previous class, polar orbits are from pole to pole, from North Pole to South Pole, around 90-degree inclination. A very special type of polar orbit is called polar sun synchronous orbit. I will talk about that, but there is one more concept here, simple concept which we should know about. Is geotransfer orbit. Give this heading. जैसे नेक्स्ट टाइम अभी एक न्यूज़ देखोगे आप, इसरो ने अपना कोई कम्युनिकेशन सैटेलाइट लॉन्च किया है GSLV यूज़ करके, एंड द न्यूज़पेपर विल टेल यू दैट दिस सैटेलाइट वाज launched into a geotransfer orbit. They will not say geosynchronous or geostationary. They will say geotransfer orbit. We do not have very powerful rockets compared to other space agencies like NASA or even some private companies like SpaceX. ISRO के जो rockets हैं, they are not very powerful. So we often rely a lot upon changing the orbit once we launch a particular spacecraft or a particular satellite. जैसे चंद्रयान 3 में भी हम डिस्कस करेंगे इसको, आदित्य L1 में भी डिस्कस करेंगे that how first we will send something earthbound and then gradually we will raise the orbit. So let's say this is Earth, and let's say that I have this desirable geostationary or geosynchronous orbit which I have to achieve. So using our rocket, when we launch a satellite, the initial orbit will look something like this. It will be a highly inclined orbit. अगर हम इस orbit को complete होने दें, so this orbit will look like an ellipse जिसका apogee will be in the range of 36,000 kilometers and perigee will be about, let's say, 200-300 kilometers. So there will be a huge difference between perigee and apogee and highly elliptical orbit. But once it reaches to the perigee or even at apogee, we can give it a boost. I told you satellites do contain some fuel. They also have their own motor. They have their own arrangement. And we can raise this orbit. So the next orbit may look something like this now. So ये जितने भी temporary orbits हैं, ये permanent orbits नहीं है. These are like parking orbits. That यहाँ पे पहले हम park करेंगे and एडिक्वेट टाइम पे, अप्रोप्रिएट टाइम पे हम इस ऑर्बिट को ग्रेजुअली चेंज करते रहेंगे. तो जो बीच के टेम्पररी ऑर्बिट्स हैं, दिस टेम्पररी ऑर्बिट्स आर कॉल्ड जियो ट्रांसफर ऑर्बिट. एंड वंस वी रीच दैट डिजायरेबल geostationary or geosynchronous, that's it. After that we do not have to do anything there. तो आप लिख सकते हो in geotransfer orbit, before launching into desired geosynchronous orbit, before launching into desired geosynchronous orbit, geosynchronous orbit, satellites are first launched into a highly elliptical orbit, highly elliptical orbit with an apogee in the range of 36,000 kilometer, apogee in the range of 36,000 kilometer. When the satellite reaches to its perigee or apogee, when the satellite reaches to its perigee or apogee, a boost is given to raise the orbit. A boost is given to raise the orbit. Boost is given to raise the orbit. All the temporary orbits before the desirable orbit, all the temporary orbits before achieving desirable geosynchronous orbit, all the temporary orbits before reaching the desirable geosynchronous orbit are called geotransfer orbits. Are called geotransfer orbits. Geotransfer orbit. In the slide you have mentioned one sidereal day as 23 hour 59 minute 4 second. That's an error. I don't know why I have not rectified it. Slides में 59 minute लिखा हुआ है. The correct answer is 56 minutes. The sidereal day that is 23 hour 56 minute 4 second. Now that you have reminded, I always think that I will go to home and change that, but I forget that. I have few questions here asked by UPSC in previous year examinations. Almost after every topic, we'll also take a quick quiz of about 20 to 25 questions. So once we complete space technology, I'm going to take a quick quiz also. Apart from that, we will be discussing previous year questions in the class. Let's start with these two questions. Let's start with this question first. Both of these are asked by UPSC in previous years. I want more responses. Online students also. Why is C not correct? Anyone can tell. By the way, answer is D. So yes, answer is D. But why is C not correct? Yes, the reason it is not correct because the word speed is mentioned. अगर यहीं पे अगर हम velocity लिख दें यहाँ पे, then that would have been a correct statement. So UPSC was quite wise in choosing the appropriate word. That last option essentially is telling you provides the necessary acceleration, which basically is centripetal acceleration. And remember, mass times centripetal acceleration is that force, right? So the question is that this is so because the attraction of Earth, which is gravitational pull, provides the necessary centripetal force and hence the necessary centripetal acceleration. So D is the correct answer here. But अगर C में यहाँ पे speed के बजाय word velocity रहता, तब भी ये correct statement होता. So that is why in current form C is not correct because the word which has been used is speed, which is a scalar quantity. This question? ये easy है, right? A satellite is said to be in such an orbit when orbit is geosynchronous. Yes. The orbit is circular. Yes. The orbit lies in the plane of Earth's equator. Yes. The orbit is an altitude of 22,236 kilometer. 35,786. अगर ये miles होता तो ये सही होता. But because we live in India, we do not have to use the stupid unit of miles. Miles is quite a stupid unit. We should always and always use kilometer. It's a better unit to measure distance. So D जो है correct नहीं है, fourth correct नहीं है. Answer here is A, 1, 2 and 3 only. Questions from science and technology will not be difficult. No matter, I am going to, अभी तो चलो आसान टॉपिक चल रहे हैं, बहुत सारे टेक्निकल टॉपिक्स भी आएंगे, कॉम्प्लेक्स टॉपिक्स आएंगे आगे क्लासेस में. एंड प्राइमा फेस इट में सीम लाइक दैट ये तो बहुत ही मुश्किल है, यूपीएससी क्यों पूछती है ऐसे टॉपिक्स पे. बट यूपीएससी के जो क्वेश्चंस होंगे वो मुश्किल नहीं होंगे, वो बहुत अटेम्प्टेबल क्वेश्चंस होंगे. एंड अ वेरी बेसिक लेवल ऑफ अंडरस्टैंडिंग अबाउट द मोस्ट इंपॉर्टेंट टेक्नोलॉजीज राइट नाउ विच इज बीइंग वर्कड अपॉन is very important, because remember, you are going to be a bureaucrat who will decide policy design for our nation. So think of how IAS officers feel superior in front of other officers. But now think of you go into a meeting, you are sitting with scientists and they laugh behind at your back कि कौन है, कौन बना दिया इसको, so कुछ समझ नहीं आता. So that is why even understanding some of the most difficult topics, for example, I'm going to also discuss quantum technologies or spectroscopy, and a lot of those things. And a basic understanding of all of those topics is very important for you. Anyways, give the next heading, Sun synchronous orbit. सब में यहाँ पे भी जितने भी हमारे इंटरप्लानिटरी मिशंस हैं, लूनर मिशंस हैं, हम एक बार में, हमारे पास ऐसा रॉकेट नहीं है कि हम एक बार में एस्केप वेलोसिटी दे दें. So first we launch into a earthbound orbit. हम gradually उसको raise करते रहेंगे, and at the appropriate time we will give them a speed so that it escapes the Earth's gravitational force and it starts its own path wherever we have planned to. Right? So even in Mangalyaan or Chandrayaan 3 or Chandrayaan 2 or Chandrayaan 1 for that matter, every such mission we will be using such type of orbital maneuver mechanism कि हम orbit को change करते रहेंगे. Rocket का काम है अर्थबाउंड ऑर्बिट में भेजना. बट मेनी अदर एजेंसीज, जैसे आपने लास्ट जब चंद्रयान 3 न्यूज में था लास्ट ईयर, तो आपको याद है एक और न्यूज में था, रशिया का एक रॉकेट था, एंड आपने देखा होगा कि इट वाज लॉन्च 20 days आफ्टर, बट इट रीच्ड टू मून फास्टर. Of course, the soft landing was not successful, but the reason it was able to reach faster because Russia has a very powerful rocket and they do not have to go into all of that orbital maneuvering. They can directly attain the escape velocity. They can cross Earth and they can go to moon. So ISRO is working on a powerful rocket. Maybe by the end of this decade, we will have a comparable rocket, but as of now, we do not have that. In first question, why not A option? Now, A तो कभी option भी नहीं था. An artificial satellite orbiting around the Earth does not fall down. This is so because of the attraction of Earth does not exist at such distance. अगर ऐसा होगा तो ऑर्बिट कभी मिलेगा ही नहीं. Right? So Earth का जो gravitational pull है, it decreases at the height, but does not become zero. Earth का technically gravitational force का formula मैंने लिखा था, capital G m1 m2 by r square. तो वी आस्क अ क्वेश्चन दैट ग्रेविटेशनल फोर्स का रेंज कितना होगा. रेंज का मतलब कितने डिस्टेंस तक हम ग्रेविटेशनल फोर्स को एक्सपीरियंस कर सकते हैं. नाउ टेक्निकली एज पर न्यूटन्स लॉ ऑफ मोशन दैट रेंज इज इनफाइनाइट, बट प्रैक्टिकली डिपेंड्स अपॉन व्हाट इज योर मास. जैसे ऑल ऑफ अस हैव मास बट आवर ग्रेविटेशनल फोर्स रेंज इज 0. इट डजंट मैटर हमारा जो ग्रेविटेशनल फोर्स है. बट नाउ थिंक अबाउट द gravitational force range of Earth that will extend millions of kilometers into sky, at least few millions of kilometers. And think of gravitational pull of Sun. So Earth and Sun का जो average distance है 150 million kilometer है, and we have the entire solar system is really huge. You have all of these gaseous planets, then you have Kuiper belt, you have Oort cloud, all of those. It's a very huge system. And solar system का जो gravity है, it extends till Oort cloud, millions, hundreds of millions of kilometers. तो जो sun का gravitational pull है, that extends into, in fact, it goes very close to billion kilometers. So it depends upon what type of mass we are talking about. So first option is simply not correct because it is not true that Earth का gravitational force अगर exist नहीं करेगा तो we can never have orbit, we can never achieve orbit. And second option is also not correct. So let's say I ask a question that if I launch a satellite which is at the height of 600 kilometer, does moon have any impact on this particular satellite? So technically the answer is yes, but does that impact it is meaningful? Not at all. It's very similar to how attraction between us is not meaningful. The moon is a very small object and it is very far away compared to a satellite which we have launched very close to Earth. So if we have launched something, let's say at even 36,000 kilometer, which is geostationary orbit, moon का जो distance है क्या है 384,000 kilometer. So 36,000, 384,000. That's a huge difference. First. And second, moon is a very small object compared to Earth. तो जो moon का impact है वो negligible है. Moon के impact के बारे में हमको सोचने की जरूरत भी नहीं है. So even second option is not correct here in the question number 1. Sorry? No, it's not. It's not because of leap year. One sidereal day is not because of leap year. Go and read about it. Leap year is simply because the revolution hai, that is not exactly 365 days. It is little bit more than 365 days. And we keep adjusting to that once every 4 years. Right? So that is why we use leap year. So leap year is because जो अर्थ का revolution है वो 365 दिन से थोड़ा सा ज़्यादा है. And hence we need to adjust that after every 4 years so that all of us are on the same time scale. Coming to topic at hand, give this heading Sun synchronous orbit. There is a question, if moon can affect sea water and cause tides, then why can't it affect the satellite? But think of all of the water of the ocean. It's quite heavy. And what is the impact? By raising up to few meter. Impact क्या है exactly sea tide का? तो पहले तो आप ये देखो, think of all of the global ocean. That's a huge mass. Compared to a satellite, जिसका mass कितना होगा? 1000 kg का होगा, इससे ज़्यादा तो नहीं होगा, कोई 10,000 kg का भी हो. But think of all of the global ocean, which is very massive. So that is the first reason. And second reason is, even with that, what is the impact? The impact is that it causes a bulge up of few meter. And this, because of this bulge, we feel that high tide or low tide as Earth rotates inside this bulge. We will perhaps in some later class, will try to understand more about the concept of tidal force. Tidal force का meaning क्या होता है? We often think of tidal force as something to do with moon attracting Earth's ocean. Tidal force is a general concept which I will try to explain in later classes, not right now. बिल्कुल कर सकता है. That's a good. So in fact, that is what tidal force does. So let me. The question he's asking is that can gravitational force change the shape of an object? Yes, it can. It can change the shape of an object, and that is what all tidal force is all about. I will talk about that in later class, not right now. Sun synchronous orbit, I'm going to divide this into 3 parts. The first 2 parts are very easy to understand. The third part, I think, is a little bit difficult because of that you need to imagine things. And imagination can be difficult. A lot of things will happen simultaneously. But the first 2 parts, they are easier and they are also more important for examination perspective. So what is sun synchronous orbit? Imagine a satellite crossing above Delhi when the position of sun in the sky was exactly above the satellite. Imagine a situation. My situation mera kya hai? That when satellite crossed above Delhi, let's say it crossed exactly at 12 afternoon. And 12 afternoon का मतलब यहाँ पे मैं local time use नहीं कर रहा हूँ. I'm using solar time. Solar time का मतलब क्या होता है? That I tried to tell the time by looking at the position of sun in the sky. Right? That I hope that everybody is clear. जैसे for example, think of the India's लॉन्गिट्यूडनल डिफरेंस, इंडिया का जो लॉन्गिट्यूडनल डिफरेंस है वो 30 डिग्री का है। 30 डिग्री लॉन्गिट्यूडनल डिफरेंस मीन 2 आवर ऑफ टाइम डिफरेंस। हम इंडियन स्टैंडर्ड टाइम कहाँ से मेजर करते हैं? वी यूज अ लॉन्गिट्यूड समवेयर इन बिटवीन विच इज 82.5 डिग्री ईस्ट। अब हम इसके बहुत पास में, हम का मतलब दिल्ली में, अगर हम दिल्ली में तो हम बहुत पास में है। तो दिल्ली में अगर मेरा घड़ी बता रहा है 12 बजे आफ्टरनून and I look at the position of sun in the sky, then yes, I will find that sun is overhead. But now think of a person in Gujarat or think of a person in Arunachal Pradesh. Will they find sun exactly above the head? They will not. So for them, the solar time will be different. स्टैंडर्ड टाइम हम इसलिए यूज करते हैं दैट जितने भी हमारे ऑफिसेज हैं, रेलवे है, बैंक है, सब एक टाइम यूज करें, पूरे इंडिया में टाइम को लेके कोई प्रॉब्लम ना हो। सो वी यूज दिस स्टैंडर्ड टाइम. But ideally, when we use the word solar time, then I'm saying that I'm looking at the position of sun in the sky, and based on that position, I'm telling what time of day or night it is. In case of night, it will be moon. So when I'm saying 12 afternoon solar time, then I'm essentially saying that sun is exactly above my head. अब इसको समझना ज़्यादा आसान है. Think of a satellite crossing over Delhi, and the position of sun is exactly above this particular satellite. Because this satellite is earthbound, right? Satellite जो है अर्थ से इसका ओरिएंटेशन फिक्स्ड है, कुछ इंक्लिनेशन है, मान लेते हैं इसका इंक्लिनेशन 30 डिग्री है. That inclination, that orientation does not change with respect to earth, but earth is changing with respect to sun because of the fact that it is revolving around sun. And everything which is bound to earth and or which is not changing with respect to earth, उसका भी पोजीशन सन के रेस्पेक्ट में चेंज होगा. ये बहुत क्लियर है ना? What is my problem statement? That earth is revolving around sun. Because of that, earth's position with respect to sun every day is changing. Not because of rotation. Rotation वाला हमने डील कर लिया. I'm particularly interested in the revolution. That as earth revolves around sun, its position every day is changing. In fact, I can tell you the angular change in position. Earth is revolving into an orbit, and one complete revolution is how many degree? 360 degree. One complete revolution का तो ही मतलब होता है ना. Earth has completed 360 degree of revolution in how much of time? 365 days. So on an average, per degree angular change is about 1 degree. I'm approximating that to be 1 degree. It will be about 0.96. I'm saying that to be 1 degree. तो जो अर्थ का पोजीशन है with respect to sun, it changes 1 degree every day because of the fact that earth is revolving around sun. And anything which is earthbound or whose orientation does not change with respect to earth, that will also change with respect to sun 1 degree every day. What does that mean? That when this satellite, which crossed today at 12 afternoon, solar time, when it crosses Delhi the next, whenever, tomorrow, day after tomorrow, whenever it crosses, it will not be 12 solar time. It will not be a case where sun is exactly above my head. Maybe it is crossing above Delhi when it is 3 in the evening, or maybe it is 4 in the morning, but it does not have to be 12. In sun synchronous orbit, my goal is that whenever this satellite crosses above Delhi, if it is crossing at 12, then I want whenever it crosses above Delhi, it crosses at 12 only. That whenever it crosses above Delhi, I want the position of sun in the sky with respect to this satellite more or less same. Hence the word sun synchronous, that I want to synchronize with respect to sun. So this is what we are trying to do. My question was, what are we trying to do? What I'm trying to do, I want to maintain that ये satellite का जो orbital orientation है, ये sun के respect में change नहीं हो. So that whenever it crosses a point on earth, the position of sun in the sky more or less remains the same. That sun is not, मान लो आज afternoon है तो कल after midnight है या कुछ evening है. We do not want that. We want that position of sun does not change each and every day as the satellite crosses above a point on earth. So this is what we are doing. Now why we are doing that? That is a very important question again. Why we are doing that is very simple, because we want to collect data about a particular location on earth in the same amount of lighting and shadow. because a particular satellite will have lifetime of about 5 years, 10 years, even 15 years. And I want to monitor changes on Earth's surface. जैसे मान लो ये जो सैटेलाइट इसरो ने लॉन्च कर रखा है, मान लो कोई सैटेलाइट है, एंड इस सैटेलाइट का पर्पस है कि इंडिया में और मान लो दिल्ली में, दिल्ली का जो ग्रीन कवर है, दिल्ली में जो भी फॉरेस्ट बचा हुआ है, वॉट एवर फॉरेस्ट कवर देयर इज, हाउ दिस फॉरेस्ट कवर इज चेंजिंग. बाय द वे वी कैन डू दैट, वी कैन मेजर दैट. सो आई वांट टू मेजर द फॉरेस्ट कवर चेंज इन दिल्ली विद द हेल्प ऑफ अ सैटेलाइट. I want to collect that data. But ideally, if I collect that data in different lighting and shadow, then it's not a very comparable data. It's even very simple, like clicking your picture. And in clicking picture, how much lighting plays a very important role. Light का जो understanding है बड़ा important. आज मुझे तक तो नहीं आया आज तक. As per my wife, मुझे समझ नहीं आता है कि lighting का क्या role होता है picture लेने में. But you get the idea that lighting and shadow plays a very important role in the quality of a picture. So similarly, when I want to collect data about Earth's surface for, let's say, 10 years, a particular location, then I want to collect that data in the same amount of light and shadow. Because I do not want this one extra variable. हम 2 या 10 या 100 डेटा पॉइंट को कंपेयर कर रहे हैं, एंड हमारे पास एक एक्स्ट्रा वेरिएबल है कि ये डेटा हमने इवनिंग में लिया था, ये मॉर्निंग में लिया था, ये आफ्टरनून में था. आई डू नॉट वांट टू बॉदर बाय दैट. सो साइंटिस्ट्स वांट टू कंपेयर दैट डेटा, and that data quality they want to maintain, that it was collected in the same lighting and shadow. That is very useful for Earth observation satellite. So sun synchronous orbit, what are we trying to do? We are trying to ensure that when a satellite crosses a point on Earth, the position of sun in the sky for this satellite does not change a lot. It is more or less the same position in the sky. And why are we trying to do that? Very simple. We want to compare data about a particular location across years without worrying about that there have been some extreme changes in lighting and shadow. And that can be quite useful for scientists when they are monitoring various type of data. How do we achieve that? That's a different thing. But first write it down. In sun synchronous orbit, in sun synchronous orbit, satellite's orientation is fixed relative to the sun throughout the year. Relative to the sun throughout the year. Thus, whenever a satellite observes a given ground location, whenever satellite observes a given ground location, the position of sun in the sky for the satellite, position of sun in the sky for the satellite remains the same. This is very useful for Earth observation satellites. Because scientists can compare data. This is very useful for Earth observation satellites because scientists can compare data across several years without worrying about extreme changes in lighting and shadow. write down, it is achieved at height of 600 to 800 kilometer, 600 to 800 kilometer, 600 to 800 kilometer at an inclination of about 96 to 98 degree, at an inclination of about 96 to 98 degree, 96 to 98 degree. तो चूंकि 90 डिग्री के इतना पास है, वी ऑल्सो कॉल इट पोलर सन सिंक्रोनस ऑर्बिट. सो जो सन सिंक्रोनस ऑर्बिट है, वी ऑल्सो कॉल इट PSSO, पोलर सन सिंक्रोनस ऑर्बिट. आप ब्रैकेट में लिख लेना, वी ऑल्सो कॉल इट PSSO, पोलर सन सिंक्रोनस ऑर्बिट. Now let's come to the last part. How do we achieve sun synchronous? Give this heading. How do we achieve sun synchronous? How do we achieve sun synchronous? How do we achieve sun synchronous? ज़रूरी नहीं है. The question is asking that will it cover a particular location on each day? That's not necessary. Why is it not necessary? I will come to that. Because this orbit, so my problem statement was that if something is fixed with respect to Earth and Earth in itself is changing with respect to Sun, that something which is fixed with Earth will also change with respect to Sun. Now I am saying that it is now fixed with Sun. So clearly it is changing with respect to Earth. ये तो बहुत clear होना चाहिए. That if it is fixed with Sun and Earth is revolving around Sun, then clearly it is changing with respect to Earth. जो satellite का orbital orientation है, that is not fixed. The orbit in itself is changing. But I just told you that orbit तब तक नहीं change होगा जब तक हम कोई fuel use ना करें. और इतना फ्यूल हम कैरी करते नहीं है कि हम 5 साल 10 साल तक हम फ्यूल यूज करके हम इसको ऑर्बिट चेंज करते रहे. So how do we achieve sun synchronous then? And this is where things become little bit complicated and also very interesting. Here the mass asymmetry of Earth plays a very important role. The Earth is not a perfect sphere. We have talked about that. There is bulge on the equator and there is flatness on the polar areas. जो Earth का radius है वो exactly 6400 kilometer नहीं है. It is less at pole, it is more at equator. That is why at equator you are going to feel less weight compared to at poles. आप अर्थ के सेंटर से ज़्यादा क्लोज हो आप पोल पे, तो सेंटर से अगर आप ज़्यादा क्लोज हो तो जो आपका एक्सेलरेशन ड्यू टू ग्रेविटी है वो ज़्यादा होगा, वो 9.8 नहीं होगा, वो करीब करीब 10 हो जाएगा. तो पोल पे जाके आप अपना वेट मेजर करोगे वेइंग मशीन लेके तो आपको ज़्यादा दिखाएगा और आप परेशान हो जाओगे. Why is it happening? So it's simply happening because that weighing measurement, it is actually measuring the weight part and it is converting that weight into mass. And your mass will be shown extra. Now your mass is still the same, but your weight has increased because turns out that if an acceleration due to gravity, that small g which we talked about, that is not same throughout the Earth. It changes, it increases from equator to pole. Now that's a separate thing. The second thing I want to mention here is that because of the fact that Earth is not a perfect sphere, जो highly inclined orbit है, that mass asymmetry causes a torque on the orbit. It causes a torque in a way that Earth का जो mass asymmetry है, it would want to change an inclined orbit into equatorial orbit. But because satellites themselves are moving, अब ये थोड़ा यहाँ पे vector mathematics आ जाएगा जो हमको करने की जरूरत नहीं है. But what happens is that rather than this, what starts happening is this. That I cannot rotate it by 360 degree, but you get the idea. That satellites orbit, जैसे मान लो अभी orbital plane ये है, but this orbital plane in itself does not remain fixed. It starts rotating. That orbit in itself starts rotating. And this is a very special type of motion, which you only know if you have studied mechanics in graduation, not even in class 11th and 12th. This motion is called precessional motion. There is a very special type of motion. जैसे अभी तक हमने पढ़ रखा है motion on a straight line, motion in circle. We have read about rotational motion also, like door को जो हम open close करेंगे, that is rotation. All of that we have studied. But now I am introducing you a new type of motion, which is called precessional motion. And you all have actually witnessed precessional motion whenever you have seen a top rotating. लट्टू अगर आपने बचपन में खेला है तो imagine a top now. Top rotates on its axis, but is this axis fixed? This axis is not fixed. That axis in itself is changing into a circle. So such type of motion where the axis of rotation in itself changes, such type of motion is called precessional motion. It's a very complicated motion, but it does exist in nature. In fact, even Earth का जो आपने क्या पढ़ रखा होगा कि Earth का जो axis है 23.5 degree है vertical से. What if I tell you that that is also not fixed? जो Earth का axis है, that also rotates very slowly, but it rotates. It completes one complete rotation in about few 20-30,000 year. तो हमारे डे टू डे लाइफ या 10 साल या 20 साल में हमको कोई फर्क नहीं दिखेगा बिकॉज ये बहुत स्लो रोटेशन है. सो व्हेनेवर यू हैव अ मोशन लाइक दिस, whenever you have a motion like this where the axis of rotation, that red line which you see, that is axis of rotation. That axis of rotation in itself is not fixed. That axis of rotation in itself is rotating. This motion is called precessional motion. So what happens in case of satellites launched into high inclined orbit, that this orbit precesses. This orbit in itself starts rotating, and that's, by the way, not a good thing. Because think of a country like America. जैसे हमको तो बहुत high inclined orbit की जरूरत नहीं है. We are very close to equator, right? So we do not need very high inclined orbit. But think of a nation like, or all the countries which are in temperate region, European nations or North American countries, or even South America में जो बिल्कुल lower latitude पे. So think of these countries. They are very much dependent upon launching satellites into highly inclined orbit. But because of mass asymmetry of Earth, this orbit in itself changes. And that's not often desirable. It's not a good thing. It's actually is a challenge. So from time to time, what space agencies will do is that whenever that orbit has changed a lot, remember satellites do contain some fuel, there is a motor, and they will use that fuel and motor and they will place it back into its original orbit. So from time to time, they will do this course correction. But in case of sun synchronous orbit, we do not do any course correction. What is a challenge? We use this as an opportunity. It's a mathematical calculation, a complex calculation, but it has been done and we know the answer, that now we have to find an inclination and a height where that precession matches exactly the change in Earth's position because of its revolution, which is 1 degree every day. So now think of a satellite's orbit. This orbit is precessing. Imagine this orbit in itself is changing. Now it's not changing like that this polar becomes equatorial. This change is like this, that within pole it is changing. And that change is 1 degree every day. And that 1 degree change is happening in a way that it is cancelling the change in position of Earth with respect to sun because of the fact that it revolves around sun. तो सैटेलाइट अभी भी अर्थ के अराउंड रिवॉल्व कर रहा है, बट जो सैटेलाइट का ऑर्बिट है वो फिक्स नहीं है. इट इज चेंजिंग इन अ वे with respect to Earth that it maintains a fixed orientation with respect to sun. And for all of that, we do not have to use a single drop of fuel. All of that is happening because Earth is not a perfect sphere, which immediately tells you कि अगर Earth perfect sphere होता, then we would never have achieved sun synchronous orbit. Sun synchronous होने का कोई चांस ही नहीं होता. So sun synchronous orbit does exist because Earth is not a perfect sphere, and what is a challenge often, we use this challenge as an opportunity in case of sun synchronous orbit. I will also demonstrate this, but पहले एक बार just write it down. Earth is not a perfect sphere. Earth is not a perfect sphere. Because of that, for high inclined orbits, there is a torque which causes satellites orbit to precess. अब ब्रैकेट में लिख सकते हो, precessional motion means when the axis of rotation in itself is rotating. Precessional motion means when the axis of rotation in itself is rotating. Right on. This is often a challenge. Such precession is often a challenge. Such precession is often a challenge. But in case of sun synchronous orbit, in case of sun synchronous orbit, in case of sun synchronous orbit, we use this challenge as an opportunity. We use this challenge as an opportunity. We use this challenge as an opportunity so that orbital precession, orbital precession cancels out change in Earth's position around Sun, change in Earth's position around Sun, change in Earth's position around Sun due to Earth's revolution, comma, for the satellite's orbit. For the satellite's orbit. For the satellite orbit. This is what precessional motion is all about. This is what sun synchronous orbit is all about. I will try to show this. I would need you or either of you. Can you come here on the stage? I will show you how sun synchronous actually functions. आगे बैठने के नुकसान है कि नहीं? Imagine this mobile flashlight at sun and Earth is revolving around sun here. Now, even if I change the position of mobile phone, it has the same effect. I am going to keep Earth stationary and I'm going to change the mobile phone flashlight. It will have the exact same effect. Or in fact, आप इसको stationary रखो, मैं Earth को ही revolve करा लेता हूँ. So this is sun in solar system. In my frame of reference, sun is stationary and Earth is revolving around it. So now think of this particular orbit. Let's say this is a sun synchronous orbit. And as this Earth revolves around sun, as it revolves, let's say by 90 degree, right now the orientation, and think of the orientation here. It's not same. The orientation has clearly changed. Here it was 90 degree angle. Here it is 0 degree angle. But now what I want, that as Earth revolves around sun, this is also changing. This is also changing in a way that all the time it maintains orientation of that same orientation which we started with. So every day I want to have a precession of 1 degree in a way that it cancels out position of for the satellite, not for, of course, Earth का हम revolution का कुछ नहीं कर सकते, but for the satellite, I want to cancel the effect of Earth revolution so that it can maintain fixed orientation with respect to sun each and every day. So that is what sun synchronous orbit is. And I will repeat, we would never have been able to achieve sun synchronous orbit agar Earth perfect sphere hota. Because Earth is not a perfect sphere, we can achieve sun synchronous orbit. Right? Thank you. Thanks a lot. Please clap for him. Thank you. Any questions till now if you have? Yeah, satellite is always revolve, yes. All the satellites which we have talked about till now, we are only talking about revolution around Earth. That goes without saying. देखो सबसे पहले तो डाउन एंड अबव का कोई मतलब नहीं होता है. पहली चीज तो ये क्लियर कर लेते हैं कि डाउन अबव का कोई मीनिंग ही नहीं होता है. इट डिपेंड्स अपॉन आप कहाँ पे हो. जैसे आपको लगता होगा कि सदर्न हेमिस्फेयर हमारे लिए डाउन है, उनको लगता है कि नदर्न हेमिस्फेयर डाउन है। सो डाउन एंड अप का कोई मीनिंग नहीं है, बट एनीवेज गो कंटिन्यू द क्वेश्चन। हम्म। Nothing happens to it. So the orbit will look something like this. Oh, I understand your question. Every time, so this is the first orbit, but it did not reach to the same point. It changed a little bit. So every day the orbit is changing. That change is happening in a way that it is cancelling out Earth's revolution around it. So that is what happens, right? We can think of it like this. You can think of it like this, that because if I actually trace it in a Earth frame of reference, then yes, it is changing a little bit. Every day जो orbit है, that is changing a little bit. तो हर दिन का अगर हम orbit बनाएंगे, it will not be one orbit, it will be multiple orbits. But in 365 days, it will come back to its same point. जहाँ से start हुआ था, it will come back to its same orientation. I can show you an animation of sun synchronous orbit. I was able to find a good video for sun synchronous orbit. In this particular animation, the satellite is crossing somewhere in North America at a particular point, and this is a sun synchronous orbit. So that yellow point and that blue one is the satellite. And as it completes multiple orbits around Earth, the orbit in itself is changing. But when next time it reaches again to the same point somewhere in Alaska in North America, so the situation will be exactly like how it started with when it is going to cross above a particular point on Earth. It is going to cross when the position of sun is more or less same in the sky. So that's the beauty of sun synchronous orbit. It's quite helpful, and that is why you'll find that most of the polar orbits, they are nothing but sun synchronous orbits only. You'll come across that ISRO has launched a remote sensing satellite into a sun synchronous orbit. So only remember three things here in this entire topic. Remember what it is, remember how is it happening, and why is it happening. उसमें बस दो चीजें हमको याद रखना है. You just have to remember that this orbit is precessing, or if you think that precession is a difficult word, just remember that this orbit is changing, and this change is happening in a way that it is neutralizing the change in position of Earth because of its revolution around sun, which essentially means that the orbit has to change 1 degree every day, because Earth is also changing by 1 degree every day. But this change has to occur in the opposite manner, in a way that it is cancelling out position of Earth due to its revolution around sun. Itna, if you can remember this 2 line about why part also, it's more than enough. Just remember that there is a change of 1 degree every day for the sun synchronous orbit, approximately 1 degree every day, and that change is because of Earth's mass asymmetry. That's the beauty of it. We are not using any fuel to cause that change. We are simply utilizing the fact that Earth is an asymmetric shaped planet. It's not a perfect sphere. Yes. एक फिक्स पॉइंट को ऑब्जर्व तो हमको करना भी नहीं है. दैट वाज नेवर आवर गोल इन केस ऑफ पोलर ऑर्बिट. ये जब भी, जैसे मान लो एक पॉइंट को ऑब्जर्व करेगा, कितना 2-3 मिनट के लिए करेगा, ये हमारा सेम है. रिमेंबर इसका हाइट कितना है, 600 किलोमीटर है. 600 किलोमीटर का मतलब है कि ये जो ऑर्बिट होगा, एक ऑर्बिट विल बी अबाउट व्हाट, लेट से 100 मिनट. तो एक पॉइंट ऑफ अर्थ को, जैसे मान लो दिल्ली को ऑब्जर्व अगर कर रहा है एक सैटेलाइट, तो हार्डली 2 से 3 मिनट के लिए करेगा, इससे ज्यादा टाइम के लिए नहीं करेगा. सो वी डू नॉट वांट this satellite to observe only one point all the time. We can only do that in case of geostationary. There is not a single other orbit where you can only observe a specific area all the time. That is only possible in only one orbit, which we call geostationary. In all other orbit, all the time position of satellite is changing around Earth. Sorry, you have to be louder. हाँ तो बट डेटा कलेक्शन के लिए हमको एक ही जगह पे बहुत ज़्यादा देर रहने की ज़रूरत नहीं है. अब मुझे मान लो कोई एक सिंपल सा समझ लो कि मुझे इस क्लास को ऑब्जर्व करना है, मेरे लिए एक स्नैप काफ़ी है. एक सेकंड में मैंने स्नैप लिया, मैंने क्लास को ऑब्जर्व कर लिया. आई एम गोइंग टू लुक एट द पिक्चर, आई विल सी ऑल ऑफ योर फेसेस इन माई पिक्चर. I do not have to keep my mobile phone all the time here. So just even one snap, which is going to take, let's say, a second, in fact, for that matter, that is more than enough to know the overall the composition of this class. So similarly, even for satellite, when they are observing a particular location, one few minutes are more than enough. Next time, they will come back to the same point, perhaps next day or whenever they are going to come back to the same point, again they will do the observation. Third time, fourth time, all of that across 5-6 years. But all the data they have collected, they have collected in the same light, and hence we do not have to worry about that maybe lighting has changed my data quality. Right? So if changes are happening, because those changes actually are happening. It's not because my lighting was good or my lighting was bad. That is the meaning of sun synchronous orbit. Yes. रिवॉल्व करती हैं. सॉरी सॉरी फिर से बोलना. हम्म. क्यों हो जाएगी ऑब्जर्वेशन हर कंट्री के? आप इक्वेटर के अराउंड घूम रहे हो. You're revolving around equator, how can you observe each and every part? In any case, it is at very high altitude. ये 36,000 किलोमीटर है, आपका जो डेटा होगा बहुत बढ़िया नहीं होगा. एंड अगर आप उल्टा घूमोगे, कुछ सारे कंट्रीज इस डायरेक्शन में घूम रहे हैं, कुछ इस डायरेक्शन में घूम रहे हैं, दैट विल लीड टू कॉलिजन, बिकॉज रिमेंबर जियो स्टेशनरी इज ओनली वन ऑर्बिट. नाउ देयर वाज अ क्वेश्चन इन लास्ट क्लास दैट टू सैटेलाइट्स कोलाइड. It's a very rare phenomena because space is really huge. Just because I'm making a picture on board does not mean space is really huge. So we have lot of space. Literally, we have lot of space where we can park a satellite, where we can launch a satellite. But geostationary is only one orbit. And I do not want satellites to revolve, some satellites in one counterclockwise and other satellites in clockwise direction. That will not function. That will lead to accidents. We do not want that to happen. So whatever we decide, either following Earth's rotation, but following Earth's rotation makes more sense because I want it to be geostationary. But even if we do decide going opposite to it, even then all countries have to follow the same thing. But that does not change a little bit. मैं ऐसे घूमूं या ऐसे घूमूं, the type of data I'm going to collect doesn't matter. It will be the exactly same. And in any case, because it is such at high altitude, that my data quality is going to suffer. So geostationary often is used for spy satellite, but only to look at some huge events. जैसे मान लो किसी ने न्यूक्लियर बॉम्ब एक्सप्लोड किया, ईरान ने न्यूक्लियर बॉम्ब एक्सप्लोड किया, and America wants to know about it. So for such type of powerful events, spy satellites will be helpful. But smaller changes, minor changes, for that going to geostationary does not make sense. For that, we will go to polar orbit at height of 600, 700 kilometer, where the data quality will be really, really good. Just say, for example, if I want to understand how glaciers are melting, then I do not have to go at 36,000 kilometer. I can do that at 600 kilometer. Not necessarily, but generally जब भी हम polar orbit, the question is that are all sun synchronous orbit polar orbit, or your question is in fact opposite, that when we launch a polar orbit, do they automatically become sun synchronous? Not necessarily. Let's say for example, if I go at polar orbit of 1000 kilometer, then it will not be sun synchronous. ये जो 1 degree precession है, it is only achieved at respective inclination at respective height, based on the mathematical calculations, and we can do those mathematical calculations. So not all polar orbits are sun synchronous, but sun synchronous we try to achieve at an inclination very close to 90 degree, so that we also get the benefit of polar orbit, which we discussed in the last class. What is the life of a satellite? Depends upon what type of function it is playing. Generally, it will be minimum 5 years, but it can be more than that also. Not getting what bulge is making Earth to precess. Bulge is not making Earth to precess. Bulge is making, just a second. Bulge is, there are some online queries. Bulge is making the satellite's orbit to precess. And why you are not getting that? Because to actually go into that, we need to go into vector mathematics. That Earth का जो mass asymmetry है, how it causes a torque. ये इस पे जाने की हमको कोई ज़रूरत नहीं है. Requirement ही नहीं है इस पूरे क्लास में. I'm only making a statement here that अर्थ का जो बल्ज है और अर्थ का जो मास एसिमेट्री है that causes a torque here. I want you to accept that statement. I know that it is difficult statement to accept, but believe me, there is a very well established mathematics behind it, that why is it happening. We actually understand why is it happening really well. What satellites after that? What happens to satellites after that? That is a question, that once satellites comes to an end, then what happens to satellite after that? Let me come to the topic of space debris. That will be my last topic, and I'm going to discuss about this. You had some question. Okay, so how do I ensure that when I go from here, I am going to reach to home? I have to go, यहाँ से मेरी क्लास खत्म होगी तो मैं घर जाऊंगा. तो how do I ensure that? So gravity का तो work तब होगा once this satellite. The question he was asking is that how do we ensure that we go to equatorial or polar orbit? So we know where we have to go, and we know which path I have to take. The same way I know that I have to go to my house and what will be the road to my house. I know that. So similarly, ये तो सबसे आसान चीज़ है. पूरे rocket launch में सबसे आसान है. That, but your question is that does gravity play? Now gravity, in the first case, when we are launching a rocket, gravity is a challenge for us, because we have to overcome this gravity so that we can attain very high speed with the help of a rocket and launch a satellite into a particular orbit. But once we launch that into an orbit with enough speed, now gravity is going to help us, because of this gravity now we are making a revolution. तो पाथ कौन सा लेना है वो रॉकेट हम पहले से डिसाइड करेंगे. रॉकेट किस एंगल पे, कितने स्पीड से, सेपरेशन रॉकेट का कब होगा, ऑल ऑफ दैट वी हैव रियली पावरफुल कंप्यूटर्स विच कैन डू कैलकुलेशंस. एंड जो भी चीज़ें हम करेंगे सब कुछ प्री प्लान्ड होगा. ऐसा नहीं है दैट हम as we are launching rocket we are deciding कि अब क्या करें. Rockets as of now have very powerful computer systems, and in fact in many things we do not do anything now. Past में ऐसा होता था कि we used to give instructions from the ground. We do give instructions from the ground even today, but most of those instructions are pre-programmed now. That there is a computer here, and that computer has all of this data, at what height, at what velocity, what type of command has to be executed. Most of those things become autonomously now. So rockets have become really intelligent in last few decades. That was my entire point in the previous class. That is the beauty of polar orbit. आप पिछले क्लास में आए थे तो यही मैंने पोलर ऑर्बिट का बेनिफिट यही है that I have a satellite which is revolving in a polar orbit, because Earth is rotating below it and satellite is revolving in polar orbit. As it revolves around Earth, every point on Earth is going to be in line of sight. It will be able to observe in each and every point. So that is the precise benefit of polar orbit, which I spent a lot of time in the previous class, in fact, that why polar orbits are useful. नहीं तो यहाँ पे अब पोलर ऑर्बिट का एक बेनिफिट मैंने बताया दैट वी कैन ऑब्जर्व ऑल ऑफ द पॉइंट्स ऑन इक्वेटर. अब मैं उसमें एक चीज और ऐड कर रहा हूं मैं पॉइंट कि नॉट ओनली वी कैन ऑब्जर्व डेटा अबाउट अ पॉइंट ऑन अर्थ, बट वी कैन ऑब्जर्व डेटा अबाउट अ पॉइंट ऑन अर्थ इन द सेम लाइट अक्रॉस 10 ईयर. तो हम हर पॉइंट का डेटा तो कलेक्ट कर ही पाएंगे, बट हम सेम लाइट में करेंगे. दिल्ली का जो भी डेटा हमने कलेक्ट किया है उस सेम अमाउंट ऑफ सनलाइट में किया है. अमेरिका में किसी सिटी का हमने डेटा कलेक्ट किया है, किसी रिवर का डेटा कलेक्ट किया है, वी हैव डन दैट इन दिस सेम अमाउंट ऑफ सनलाइट. So that is the beauty of polar sun synchronous orbit. There is one extra advantage here, that not only it tells you about each and every point on Earth, but it also tells you that data in the same amount of light and shadow. Let's go to the next topic. Give this heading, types of satellites. Please don't talk in the class. I'm only going to focus upon the 3 type of satellites. There can be other types also, small experimental satellite, but we do not have to worry about them. So I will only focus upon 3 type of satellites. Communication satellites, remote sensing, we also call them Earth observation. Navigational satellites. So in last class I told you that the purpose of communication satellite is to create a channel, and that satellite is like an intermediary. It is receiving signal from some transmitter. It is amplifying that signal, increasing the strength of that signal, and it's sending that signal back to Earth. And all of the devices which are tuned to that particular frequency on which satellite is functioning, all of those devices will be able to catch that particular signal. So communication, exactly how it functions, what is the role of radio waves here, all of that we will discuss in great detail in ICT, that how does communication actually function. Right now, I simply want to highlight few things, that what is the purpose, where is it launched, and most importantly, in all the areas we can use communication satellites. Write it down, few things, write down few things here. These satellites create a communication channel. These satellites create a communication channel. Communication channel between 2 points on Earth. Between 2 points on Earth, with the help of antennas. With the help of antennas, creates a communication channel between 2 points on Earth with the help of antennas. Generally, they are launched in geosynchronous and geostationary. Generally, they are launched in geosynchronous and geostationary. Geosynchronous and geostationary. अब जो इसरो का जैसे कम्युनिकेशन सैटेलाइट प्रोग्राम है बहुत सोफिस्टिकेटेड है. अर्लियर वी कॉल्ड इट इनसैट प्रोग्राम, इंडिया नेशनल सैटेलाइट. Then we renamed them and we called them GSAT series of satellites. So you'll come across all of these names, GSAT 15 or 20 or 30, 31. So G का मतलब यहाँ पे geosynchronous है, GSAT, geosynchronous satellite. But last year, in fact, sorry, 3 years ago, ISRO changed the nomenclature and all of our communication satellites will be now called CMS. So CMS 01 or 02, 03, CMS is shortcut of communication. तो आप लिख सकते हो, ISRO has one of the largest communication satellite program. ISRO has one of the largest communication satellite program in Asia Pacific region. In Asia Pacific region. And we have used this name INSAT. The earliest satellite programs, we called it INSAT. We changed the nomenclature as GSAT, geosynchronous satellite. And now we are calling it CMS. CMS is shortcut of communication. Give the heading applications. A few applications are very straightforward. radio, television. I wanted to highlight about some specific applications. For example, give this heading, telemedicine. Telemedicine. Tele का मतलब यहाँ पे tele shortcut of telecommunication, right? So what does the word telecommunication medicine mean then? It can also mean some of the apps which you use. For example, let's say if you are using Practo app. Practo app, you can have a video call with a doctor by taking an appointment. Now that is also an example of telemedicine. In this particular case, ISRO has dedicated satellites. The purpose of these satellites will be that they will establish a satellite connectivity into some remote and rural area medical hospital or college with some specialty hospital, let's say AIMS in Delhi. And doctors will train doctors and nurses of this remote area hospital college, or they can also directly diagnose a patient over the satellite connectivity. So in multiple ways, we can provide healthcare services into remote and rural areas with the help of satellite. आप लिख सकते हो connecting remote, इसी में telemedicine में just write down a line, connecting remote and rural medical colleges and hospitals, medical colleges and hospitals, medical colleges and hospitals, to specialty hospitals in cities, to specialty hospitals in cities via satellite, to specialty hospitals in cities via satellite. Similarly, I can use the word tele-education. Even tele-education can include, for example, all of the online students. That is also a type of tele-education. But for this, you are using internet as an infrastructure. And most of the internet as of now, even today, we do not use satellites for it. We can use satellites. In fact, there are some really ambitious programs which has been launched recently. Things like Starlink, which belongs to SpaceX. I will talk about Starlink in more detail in ICT classes. But you already have some ambitious plans here that let's launch satellites and let's provide global internet connectivity with the help of satellite. As of now, internet works because of optical fiber cables, that you have cables spread underground in oceans, inside oceans, and that is how all of the world is connected and billions of devices are connected. I will talk about this in detail in ICT classes. But even before internet, think about all of the free channels which are available on TV, and those channels provide educational programs. I remember as a kid watching a lot of educational programs, and even today on Doordarshan you can find many educational programs. So ISRO has dedicated satellites, and these satellites broadcast educational program, and this is available completely free of cost. You do not have to pay anything, right? So that is what tele-education is. I can also talk about few more applications. For example, I can mention about VSAT. VSAT का जो full form है, that is very small aperture terminal. Very small का मतलब यहाँ पे what it will look like. In fact, let me show you that. It is literally a small aperture. ये जो एंटीना है बहुत लार्ज नहीं है. एंटीनास जनरली जो होंगे बहुत लार्ज होंगे, जो भी रेडियो एंटीनास होंगे, जैसे यहाँ पे ही, यहाँ से हार्डली 500 मीटर आगे, go to Rajendra Nagar metro station, and there is a government agency, and there is a very large antenna you can see. That's not VSAT. VSAT, literally we are talking about small antennas. These are earth stations, and these small antennas are connected to some central hub which is connected to a geostationary satellite. अब ये small antenna होने का फायदा ये है that हम इसको कहीं पे भी deploy कर सकते हैं. I am deep into ocean. There is some ship, submarine, not submarine, but think of a ship deep into ocean, and we can deploy this. You are into defense, deployed on Himalayas, you can deploy VSAT. और अभी चलो मोबाइल कनेक्टिविटी बहुत इंप्रूव हो गया है पिछले 10 सालों में, बट 20 साल पहले भी एटीएम तो था ही, एंड आई कुड गो टू अ रूरल बैंक ब्रांच, and that rural bank branch has a computer, and that computer is connected to their central server which is located somewhere in the city. So what was the network it was using for that connectivity? It was using VSAT. So even today we use VSAT for railways, for mining companies, petroleum companies, for banking, even in stock market. There are stock brokers, जो BSE Bombay Stock Exchange and National Stock Exchange है, they also use VSAT terminals to execute certain types of orders. So this is, we are basically talking about type of ground station. Think of a device, you are connected to VSAT terminals, and these VSAT terminals have connectivity with geostationary satellites, and those satellites have connectivity with other devices or other radio transmitters. So that is how now you can transfer data to other part of the earth here. The data transfer speed जो होगा वो बहुत ज़्यादा नहीं होगा, and latency ज़्यादा होगा. Latency क्या होता है हम डिस्कस करेंगे बाद में, but there will be delay, there will be lag in data transfer, and speed will not be very good. But nonetheless, you will maintain data transfer, or you will maintain connectivity with many parts of the world. So VSATs are very useful, and सबसे बड़ा जो utility है कि इनको deploy करना बहुत आसान है. धीरे धीरे मुझे लगता है कि VSATs obsolete हो जाएंगे because of all of these programs like Starlink and OneWeb, which now you can subscribe to internet with very high speed, and you can have your own personal satellite-based internet. So maybe they will become obsolete, or maybe they will still will have some utility, at least in very specific type of services, particularly government services. So these are essentially ground earth stations. आप लिख सकते हो. These are ground stations. Yes, I'm going to take a break for in just 2 minutes. Don't worry. These are ground stations connected to communication satellites, and can be used for data transfer, The diameter is small, hence can be easily deployed. The diameter of antenna is small, hardly 2-3 meters. The diameter of antenna is small, hence can be easily deployed. It has applications in railways, banking, defense, stock market, among others. It has also applications in navigation, which I'm going to explain later. But one last thing I want to mention here is COSPA SARSAT. COSPA SARSAT is an intergovernmental program. Government agencies have come together and they create this COSPA SARSAT program. अब ये program क्या है? In this program, it is essentially a satellite-aided search and rescue program. कि कोई मान लो ship है, कोई helicopter है, कोई plane है, which is stuck into some remote area, and they will often have some emergency beacon which they can activate, and that will be connected to whatever satellite is visible or whatever satellite they can maintain connectivity to. So many space agencies are part of this program, including ISRO. तो जो इसरो के सैटेलाइट्स हैं, इफ अ प्लेन और शिप और इवन अ पर्सन is stuck in some remote area and they have access to Cospas Sarsat, then particularly in Asia Pacific region, in South Asia region to be more specific, in fact, in South Asia region, ISRO satellites can be utilized for rescue work. So it is an intergovernmental satellite aided search and rescue program. Just one line is more than enough. Write down. It is an intergovernmental satellite aided search and rescue program. Intergovernmental satellite aided search and rescue program. There is a question that are TV dish antenna VSAT? No, they are not. Because TV dish antenna जो है वो सिर्फ एक टाइप का सिग्नल रिसीव कर सकते हैं आपके टीवी के लिए. It is a satellite aided, intergovernmental satellite aided search and rescue program. About Cospas Sarsat, it is an intergovernmental satellite aided search and rescue program. TV dish antennas are not VSAT. VSATs are used for various type of data transfer. Think of VSAT as internet connectivity. That I can transfer various type of data, text, images, videos, all sort of data, and I can maintain a two-way communication. जो आपका डिश एंटीना है वो खाली सिग्नल रिसीव कर सकता है, वो खुद का सिग्नल ट्रांसमिट नहीं कर सकता. तो जो VSATs हैं, they will establish a two-way communication. So no, your TV dish antennas are not example of VSAT. SOS signals, be more specific, what are SOS signals? Then I can answer that question. Let's take a break here. After that, we will discuss about remote sensing satellites. There is a question, is Wi-Fi a VSAT? Wi-Fi is not a VSAT. What is Wi-Fi? We'll discuss that in ICT classes. Wi-Fi does use radio waves, but it's not VSAT. Give this heading, Earth observation satellites. So first thing first, from the name it should be very clear that we want to observe Earth. We also call it remote sensing. That we want to sensing का मतलब पता लगाना, measure करना. We want to know about something from remote, from far away. That is the meaning of remote sensing or Earth observation. It's very similar to what I talked about earlier, that I take a snap of all of you with my mobile phone, and then I'm looking at this data and I'm trying to figure out perhaps some important data point about this class. Perhaps I want to know this X ratio. I want to know about overall the total number, things like that. So I have collected this data. Now I'm analyzing this data and I'm trying to find information about it. So remote sensing satellites also do the same thing. The only thing is that they do not take just simple snaps. Now I want to divert a little bit. I want to digress a little bit. I will come back to the remote sensing satellite topic, but I wanted to talk more about the nature of light. And I will have this discussion in subsequent classes also. I will talk about nature of light and how light is a carrier of information. I will talk about that in ICT also. I will finish all of that discussion in the perhaps very last class when we will discuss about Dr. C.V. Raman and Raman spectroscopy. But right now, I want to specify or I want to focus upon only just one aspect of light, that how light is a information carrier. This is something which I want to talk about, that how light carries information with it, and how light plays a very important role, that we collect information, we collect data about our surrounding. For example, look at this mouse. All of you can see it because of the prevailing light in this room. This mouse is reflecting whatever light it is absorbing some light, and that reflected light reaches to my eyes and it allows me to look at this particular mouse. Right? It tells me its shape, its size, all of that. Depending upon how far it is, if I'm closer to it, I have a good idea about its size, shape. Perhaps people who are at the back, they will have difficulty. They can see it, but they will not have a lot of good idea about, let's say, its depth or shape perhaps. But nonetheless, they will be able to see this mouse. That is what I mean when I say that light is a information carrier. In fact, many type of other waves are information carrier. Sound wave is information carrier. When I'm speaking something, that sound wave, as it vibrates through air, it reaches to your eardrums. Those eardrums leads to vibration of eardrums, leads to an electrical pulse which goes to your brain. Brain makes sense of that electrical pulse, and you can listen to what I am speaking here. So even sound wave is information carrier. In this case, it is carrying what I am speaking. But light wave carries information what an object, let's say, very simple, looks like. But turns out it is much more than that. It is not just what an object looks like. Jaise, we ask a question that why this particular mouse pad is of blue color, right? We have studied this in our school days because this mouse pad is reflecting blue color the most, and hence it is looking blue color. But then the next question we should ask is that why is it reflecting blue color the most? Why is it not reflecting some other color? Will it look blue color if I use only red light in this room? Abhi white light hai. White light is mixture of all of the 7 colors, all of the 7 colors of rainbow we have studied in our school days. Out of all of the 7 color, it is reflecting blue the most. I look at blue color. Let's imagine I have a light source which only emits red light. Will it now look blue? It will not look blue. It will look some other color. Maybe it will look some gray or black color also. The color depends upon the prevailing light in the room. If I switch off all of that light, I do not see it. Does that mean this object is not here? It is still here, but I do not see it. That information about this object is lost, at least for my eyes, because my eyes are very much dependent upon visible light. So the next question we ask then, that why blue color? Why not green color? Why not red color? Why blue color? And that is a more interesting question, and we do have answer to that question also. That it actually depends upon the nature of light, the type of light, and it depends upon the nature of this object here. That इसका atomic molecular composition क्या है, and हम किस type के light की बात कर रहे हैं. And both of those factors will decide कि इस object का light के साथ interaction कैसा होगा. The point I'm trying to make here is that every object in this universe has a unique optical signature. And that depends upon the type of light, and that depends upon the type of object I'm talking about. Jaise, let me give you some concrete examples so that we can appreciate this particular point in detail. We call visible light because literally we can see it. But turns out there are many other types of light, very similar to visible light, some differences in frequency and wavelength, but our eyes cannot see. Jaise, all of us, I'm very sure, have kabhi na kabhi life mein X-ray karaya hoga. X-ray is also a type of light, but we cannot see X-ray. We have read about ultraviolet light. That is also light. We cannot see ultraviolet light. I'm very sure many of you also have read about infrared light. We cannot see infrared light. Even that radio wave, think about it. All of these windows, doors, everything is closed. And अभी तो चलो मान लो ग्लास है, ग्लास का डोर है यहाँ पे. मान लो कि वुडन डोर होता, और मान लो कि हर जगह वुडन डोर है, सब कुछ लॉक्ड है. I still can receive a phone call here, right? Very simple. Somebody is calling me, I can receive a phone call. Clearly, the wooden doors and all of those walls, they are transparent for the radio wave. So I'm now redefining the concept of transparency and opaqueness. We think of something as a transparent and opaque, but our reference point is visible light. Those 7 colors of rainbows, Vivicure, violet, blue, green, yellow, red, orange, all of those colors. But the moment this light becomes radio wave is light, by the way. And for radio wave, this wall here is transparent. It is not opaque. And now think of infrared light and think of ultraviolet light. For ultraviolet light and infrared light, this wall is opaque, but so is that glass. If I have infrared light, that infrared light cannot cross that glass. If I have visible light, it can easily cross that glass. अगर बहुत ही pure glass हो, तो उसके लिए for visible light, it's like that glass is not even there. It can easily cross it without even a lot of absorption. But same thing, same glass, I use an infrared light source, and that glass is not going to allow infrared to escape. It will now behave like this particular wall here. This can be very easily understood also. आप experiment करके देख सकते हो, करा भी होगा आपने. आप कार के अंदर बैठे हो, AC नहीं चला रखा आपने, बहुत ज़्यादा गर्मी होगी compared to बाहर. बाहर भी गर्मी है, but कार के अंदर ज़्यादा गर्मी है. उसका reason बहुत simple है. That कार का जो window है, it will allow visible light to come through that will warm up this seat. And when objects warm up, they start radiating energy. But that radiation is not visible. That radiation is infrared light. We cannot see it, but that radiation is there. So as that car seat warms up, it radiates infrared, but now this glass window, which was transparent to visible light, suddenly becomes opaque to infrared light. And all of that heat is captured inside that car, and you feel much more hotness inside the car compared to outside. The same reason why agriculture में हम green house use करते हैं. आपने देखा होगा एग्रीकल्चर में ग्रीन हाउस होता है. ग्रीन हाउस होता क्या है एग्जैक्टली? ग्रीन हाउस अगर आपने देखा एग्रीकल्चर में क्या होता है, इट इसेंशियली इज अ ग्लास हाउस. आपने नहीं देखा है ना कि जो एग्रीकल्चर में हम यूज करते हैं ग्रीन हाउस, दैट इसेंशियली इज अ ग्लास हाउस. दैट ग्लास अलाउज ऑल ऑफ द विजिबल लाइट टू कम इनसाइड. द सरफेस वार्म्स अप. Surface, when it warms up, it now starts releasing energy. It also starts radiating energy. But that radiation is not visible. That radiation is infrared. And for infrared, glass becomes opaque. तो भले बाहर ठंडा हो, अंदर ग्लास हाउस के अंदर टेम्परेचर थोड़ा बेटर होगा एंड प्लांट्स का जो ग्रोथ होगा वो बेटर होगा. Photosynthesis can occur with more efficiency inside this glass house, which we call greenhouse. Green because it literally allows plants to become greener, hence the word greenhouse. So the point I'm trying to make here is that light is not just visible light. Our eyes can see only visible light. Our eyes are optical instrument. Light is many other type of light. And how light interacts. Interaction का मतलब ये है that what type of light will be reflected, what type of light will be refracted, what type of light will be emitted, what type of light will be transmitted, what type of light will be scattered. All of that depends upon the nature of light first, and it depends upon the atomic and molecular composition of the object we are talking about. Just this LED bulb here is emitting white light. Why is it emitting white light? Clearly it is emitting all the 7 colors, and I see that as a white light. But why is it not exclusively emitting blue light? I do know that I can have a blue LED. I do know I have a red LED. So why that red LED is only emitting red light? Turns out we have answer to all of those questions. And fundamentally, it has something to do with atomic and molecular composition. I will talk about this idea in more detail in subsequent classes. Right now, my only limited point is that light is carrier of information, but it is not just visible light, which is carrier of information. Even that infrared light, if it is being captured from a particular location, that also can tell me a lot of information. Jaise, I switch off all of the light in this room. None of us can see each other, but I have an infrared sensor. And with the help of infrared sensor, I can see all of you exactly where you are, because all of us have body temperature and all of us radiate infrared. And since we radiate infrared, if I have an infrared sensor, I'll be able to see all of you exactly where you are. Those infrared sensors are called thermal sensors. The reason they are called thermal sensors, because when objects that are higher temperature, they will release infrared. So thermal sensor, infrared sensor, that is the same thing. And with the help of thermal sensor, even during night, I can know about location of objects around me. So बहुत सारे ऑब्जेक्ट्स विजिबल लाइट इमिट करेंगे, रिफ्लेक्ट करेंगे. बहुत सारे ऑब्जेक्ट्स इंफ्रारेड करेंगे, रिफ्लेक्ट या इमिट करेंगे. And I can collect that and I can gather information. But in some cases, I do not want to even rely upon the reflected light by the object because of some prevailing light. I want to actually use my own light source. I want to use my own light, and as that light gets reflected, I want to record that, and I want to know what type of object I'm talking about. Just say, what do dolphins do? Dolphins are blind, padha hoga aapne? Dolphins are functionally blind. They cannot see very well. They're very intelligent, by the way. They're mammals. They're human. Their brain is very close to human brain, and they're very intelligent. But the problem is that they do not have very well functioning eye, and they still navigate inside the water really well. How do they do that? Does anyone know? They use sound now, right? So what do they do? They emit ultrasonic sound. अल्ट्रासोनिक साउंड का मतलब ये है साउंड का फ्रीक्वेंसी जो 20,000 हर्ट्ज से ज़्यादा हो. हमारे जो ईयर्स हैं दे कैन ओनली लिसन टू साउंड above 20 hertz but below 20,000 hertz. If it is more than 20,000 hertz, we call that sound as ultrasonic sound, and our eyes cannot make sense of it. A dolphin emits ultrasonic sound. It has organs which allows it to emit ultrasonic sound. That sound, when it goes and is incident on any surface, any object, it is reflected back. Not all of that sound will be reflected. Some can be absorbed also, some can be reflected. And dolphins have sensors the same way we have eyes and ears, which are like sensors. And my eyes and ears are all the time gathering sound and light. Dolphins have really good sensors which can gather that reflected sound. How much time it took for that reflection to occur, how much sound was reflected, how much was absorbed. Based on that, it will allow them to navigate in the water. They know what type of object it is. If the object is moving, they will get to know about that. If the object is living organism, maybe it is a prey or predator, they will know about it. If an object is stationary object, a solid object which they have to circumvent through, they do not have to go and collide, they will know about it. Now, how dolphin sees the world, we will never know. We are not dolphins. But once we understand this, the dolphin uses sound wave to navigate in the world, then we can use that. Remember, technology is about applications of science. So now think of that ultrasonic sound technique which is used in cases of pregnancy, that we want to see the movement of a baby inside uterus. Now, we could have used some X-ray or some high frequency light, but that is dangerous. We do not want to cause any type of health damage here. So rather than doing that, we use ultrasonic devices, ultrasonic sound, and then we measure the reflected sound, and we can have a very good overview of baby's movement, its growth, mass, all of that. We can get a lot of information. So in this case, we are emitting sound, and then we are measuring the reflection part. When it occurs in nature, such as let's say dolphins or bats, we call this mechanism echolocation. We use a word here, echolocation. Echo का मतलब जो sound reflect होके आता है, we call it echo. And using echo, we are locating object, hence the word echolocation. Similarly, we can have devices which can emit light, and then we are measuring the reflected light, how much time it took for that reflection to occur, how much light was reflected. Based on that, we can create a very good map of a particular area. But now, one more thing, I do not have to use visible light here. I can use infrared also. I can use even radio wave, by the way. That I can have a device which is emitting radio wave, the same radio wave we use for mobile communication. And those radio waves will be reflected by a particular surface. And based on that reflection, I want to know more about that surface. And turns out that when I start using lights of various frequencies, then it's not simply the physical shape or size which we get to know. We also get to know the chemical structure, the chemical composition. We also get to know the biological properties. So when I made a statement that light is information carrier, for visible light, our eyes can only see shape and size, color. तीन चीजें हम देखेंगे, shape देखेंगे, size देखेंगे, color देखेंगे. I am saying that visible light को, infrared को, radio wave को, इन सब को use करके, it's not just shape and size and color we can know. We can also know all sort of other physical or chemical or even biological properties. So when I'm using the word remote sensing satellite, then I'm not talking about simple optical cameras. Cameras which are taking a snap in red, blue, and green color. These three are primary colors, red, blue, and green. From these three colors, we can make any other color. So I'm not talking about taking a simple snap of a particular location in red, blue, and green color. Of course, we can do that. But we are talking about really sophisticated optical devices which can use visible light, but they can also use radio wave, they can also use infrared, and they can get all sort of properties, physical property, chemical property. What are the chemicals available at a particular location? जैसे all of you, I'm very sure now have bought an atlas. सबके पास atlas होगा. आपके atlas में एक political map है, सबसे simple map है. But उसके immediately पहले या बाद में physical map है. Now, lot of that physical map, that कितना altitude कहाँ पे है mountain का, कहाँ पे river है, कहाँ पे grassland है, कहाँ पे plateaus है. Lot of that map has been prepared with the data collected by remote sensing satellite. On the next page, you have map about forest cover of India. On the next page, you have map about underground water resources कहाँ पे सबसे ज़्यादा है. On the next page, you have map about कौन से minerals India में कहाँ पे, uranium कहाँ है, iron कहाँ है, ये कहाँ है. All of those resources, where are they? And there is a very good chance that many of those maps, including mineral exploration, including water resources, including forest cover, including even physical features like topography or temperature profile, all of that map has been prepared with the help of data collected by remote sensing satellites launched by ISRO. The beauty of remote sensing satellites is that they allow you to observe, and when I use the word observation, I will repeat, it is not a simple observation which is trying to click a picture. I'm talking about really sophisticated data. And with the help of that data, we can gather all sort of information, the physical or chemical or biological properties of a particular location. Just let me show you two of the maps of India, which I have taken from ISRO's website. जहां पे भी हम प्रिवेलिंग लाइट को यूज करेंगे, जैसे मान लो सनलाइट है एंड जो रिफ्लेक्टेड सनलाइट है उसको सैटेलाइट ऑब्जर्व कर रहा है, कलेक्ट कर रहा है. Such type of remote sensing is called passive remote sensing. But I can have a remote sensing which is called active remote sensing, active in the sense that it is not dependent upon the prevailing light. I'm using that satellite has its own light source. It has some own device which can, let's say, produce radio wave or infrared light or any other type of light. And then it measures the reflected light. And based on that measurement, it knows about a particular location. I will call that active remote sensing. Just say, these are the two maps I have taken from ISRO's website. The first map is temperature profile of India from January to December. And the second map is wind velocity in the coastal regions of India. Now think about if I have a startup and I'm trying to invest in solar and wind energy. Then for me, these two maps will be quite useful because I first get to know that in which areas the solar energy capacity or wind energy capacity is very. And by the way, ये map तो चलो फिर भी पूरे इंडिया का pan India map है. I can have a dedicated map for a district. I can have the same temperature map or wind velocity map in a very specific location. And then with the help of that same remote sensing satellites, I can also look land which is available for the, let's say, solar panel installation. Ideally, that land should not be fertile land. It is not an agricultural land. मान लो बंजर लैंड पड़ा है जहाँ पे टेम्परेचर बहुत ज़्यादा है. Hopefully nearby water source भी हो ताकि electricity production में help मिले. I can gather all of that information with the help of remote sensing satellite, and that will be quite useful for me. So remote sensing satellites have applications in so many different areas. We do not use them in our day-to-day life, but government agencies, departments, but also private companies and many organizations for scientific observation, remote sensing data actually is quite useful. And remote sensing, I will repeat, is not simple type of taking picture. I have few of the techniques. There is a very famous technique called light detection and ranging, where a laser light source is used that emits laser light and then measures the reflected laser light, and based on that, it creates a beautiful map, a 3D map in fact, of a particular location. The same technology is also used in self-driving car. आपने पढ़ा होगा self-driving कार के बारे में, autonomous car के बारे में. तो जो self-driving car है, वहाँ पे जो dash होगा, front dash होगा, वहाँ पे एक lidar device होगा. All the time it will emit millions of frequencies of light, and that light, as it gets reflected by the surrounding object, it collects that and it makes a live map of that area. Now the next step will be to identify in this live map what is a traffic light, what is a person. For that we will use artificial intelligence, which I'm going to discuss in subsequent classes. So LIDAR has multiple applications, including in remote sensing satellite. This is a technology called synthetic aperture radar technology, where we have now used radio waves. We are not using visible or infrared. We are using radio waves. This is a technology called hyperspectral imaging. In hyperspectral imaging, we take picture of the same surface, but in different frequencies. जैसे मान लो, in the earlier example, this picture I, let's say, collect with my mobile phone. Now mobile phone is taking this picture in red, blue and green color. तो इसको blue color बढ़िया मिल जाएगा. But now imagine I have a device which can collect picture of the same surface in a very specific frequency, starting from, let's say, ultraviolet, then coming to visible light, and even within visible light, let's say violet, and violet may be a very specific frequency of violet, then specific frequency of blue, green, yellow, orange, red, all of that, and going to infrared also, and putting all of that picture together, and then see the properties of that particular surface. So hyperspectral imaging again allows you to know a lot about particular surface by clicking pictures into various frequencies, not just simple red, blue, and green color, which we use in our day-to-day life. So remote sensing satellites are quite useful in so many different areas. And I'm going to give you a list of applications, but that list is not an exhaustive list. I can add many more things that how remote sensing satellites have various sets of applications. So write it down. I will keep explaining it more. The purpose of these satellites, the purpose of these satellites to collect data, about particular location on Earth, remote sensing techniques are very sophisticated. Remote sensing techniques are very sophisticated. Remote sensing techniques are very sophisticated. They allow to gather information about physical, chemical, or even biological properties. Physical, chemical, or even biological properties of a particular location. Physical, chemical, or even biological properties of a particular location. Some of the techniques are, where did I put the pen? Some of the techniques are, write down in bullet points. Sorry, here it is. Some of the techniques are radar imaging, इसी में एक और sophisticated, इसी का एक और sophisticated version है, that is called synthetic aperture radar. Light detection and ranging, LIDAR, thermal scanners. Thermal scanners have such great utility in defense also. A particular enemy nation has launched a ballistic missile. अब एक तो रडार से हम चलो हम देखेंगे, but even before radar we can use thermal scanners, that whenever ballistic missiles will be launched during the launching phase, they're going to produce a lot of heat, and we can measure that heat from very far away with the help of satellite or other type of thermal scanners. Hyperspectral imaging, hyperspectral imaging, these satellites are generally kept in LEO, low Earth orbit, LEO, polar orbits, PSSO, polar sun synchronous orbit. Polar sun synchronous orbit. And even in geosynchronous or geostationary orbits, even in geosynchronous or geostationary orbits, even in geosynchronous or geostationary orbit. They have applications in multiple areas. They have application in multiple areas. Such as geology and geomorphology. Geology and geomorphology. Geology and geomorphology. Ocean science. Ocean science. Weather and climate. Weather and climate. Forest monitoring. Forest monitoring. Water resources including groundwater. Water resources including groundwater. Let me explain this. Groundwater, it cannot tell you directly. So remote sensing satellites, they cannot tell you about natural aquifers inside soil. But turns out that जहाँ पे भी natural aquifers का extent ज़्यादा, aquifer का मतलब जहाँ पे ground water resource बहुत ज़्यादा हो, तो जहाँ पे भी ground water resources बहुत ज़्यादा हो, वहाँ पे जो soil characteristic होगा, वो अलग होगा. So remote sensing satellites will tell you this indirect information about soil characteristic, and based on that, on ground, in situ exploration will allow to know about those groundwater resources. So even in case of groundwater resources, we can use remote sensing satellite. And same goes for natural resource exploration. Next, natural resource exploration. Natural resource exploration. Soil monitoring in agriculture. Soil monitoring in agriculture. Disaster management. Disaster management. How in disaster management? I can explain that with the help of, think of whenever a cyclone is about to hit the coastal areas. Let's say there is a fear of cyclone reaching to the coastal area in, let's say, West Bengal or Odisha. And you'll find that even 2-3 days before, new channels will tell you how this cyclone is, how powerful it is, how it is moving, and how it is going to move, and when is it going to fall. All of that, we try to estimate that beforehand. How do we do that? We collect data from remote sensing satellite. We analyze that data on very powerful computers. We do have very powerful computers, supercomputers. And based on that, we can estimate we can simulate the movement of this particular cyclone as it is going to happen in next 2-3 days. So even in disaster management, and accordingly, we now can convey this message to people, and we can work for evacuation and find shelters at the right time. 10-15 years ago, or 20 years ago, a lot of people used to die whenever there was a cyclone. Now the number of death is often in single digit. And the reason is because we have really good capability to collect data about the cyclones, and also to analyze this data and beforehand simulate how this cyclone is actually going to evolve. And based on that, we can work for evacuations. That is the meaning of here disaster management. One more I can add here, governance. Governance. I can add many more things. I will repeat, this is not an exhaustive list. Okay, governance का क्या मतलब है? Particularly in implementation of government schemes. जैसे let me tell you about few popular government schemes. जैसे मान लो प्रधानमंत्री आवास योजना है. प्रधानमंत्री आवास योजना का ऑब्जेक्टिव क्या है? That it aims to make low cost housing for लोअर एंड मिडिल इनकम ग्रुप ऑफ पीपल इन इंडिया। इंडिया में बहुत बड़ा प्रॉब्लम क्या रहा है कि खाली पैसे पेपर पे खर्च होते हैं। So with the help of remote sensing satellite, we can actually monitor the work which is happening on a ground. कि हम देख सकते हैं कि जो भी कंपाउंड है जहाँ पे मान लो अपार्टमेंट्स वगैरह बन रहे हैं उनका एक्सपेंशन क्या है। हमने आज डेटा कलेक्ट किया, 6 मंथ बाद किया, साल भर बाद किया, एंड वी लुक एट द प्रोग्रेस ऑफ दैट पर्टिकुलर लोकेशन, दैट हाउ दिस इज कमिंग अप। वी कैन डू द सेम थिंग, फॉर एग्जाम्पल लेट्स से नमामि गंगे प्रोग्राम, गंगा को हम पिछले 40-50 साल से क्लीन करने की कोशिश कर रहे हैं। सो थिंक ऑफ नमामि गंगे में हमारे ऑब्जेक्टिव्स हैं कि हम आने वाले 2-3 साल में वी आर गोइंग टू डू दिस, और इन 5-10 years वी आर गोइंग टू डू समथिंग लाइक दैट। सो वी कैन सिंपली लुक एट remote sensing data and see that how this is going forward. So even in governance, particularly in implementation of government schemes, we can utilize remote sensing satellite. So remote sensing satellites are quite useful for so many things. And earlier when ISRO used to launch remote sensing satellites, we used to give them different name depending upon their purpose and technology. This you will come across satellite or group of satellite called CartoSat series. कार्टो का मतलब यहाँ पे कार्टोग्राफी है, कार्टोग्राफी इज मैप मेकिंग, सो मेकिंग वेरियस टाइप ऑफ मैप्स विद द हेल्प ऑफ सैटेलाइट। और वी हैड दिस group of satellite called RESAT series of satellite, which utilized synthetic aperture radar technology for resource exploration. We had satellite called OceanSat satellite, which literally was utilized to know more about marine areas in India. You had a satellite called HISIS, hyperspectral imaging. But now all of that, it has been renamed, and we simply call of our recent remote sensing satellite as EOS group of satellites. EOS का मतलब यहाँ पे अर्थ ऑब्जर्वेशन है, आप कहीं पे साइड में एक लिख सकते हो आप, दैट जो रिसेंट ये सारे रिमोट सेंसिंग सैटेलाइट्स के एग्जांपल है इन पास्ट जो 15-20 सालों में हमने लॉन्च करा है। बट अब जो भी रिमोट सेंसिंग सैटेलाइट्स हैं, दे आर नोन एज दिस EOS group of satellite. Are we allowed to make our satellite go over the airspace of different country? The thing is that airspace does not extend to space. जो space है, there are certain things which we call global commons. मतलब वो किसी एक country का property नहीं है। जैसे even in ocean, up to let's say 12 nautical mile, आपका exclusive economic zone है. Beyond that, you have UNCLOS, there is a United Nations treaty, and that comes into play. So global oceans are not specific to one country. And similarly, even space is not specific to one country. So there are a lot of things which we call global commons, that they do not belong to one country. So जो satellites going over airspace of a different country, that question does not even arise, because your airspace does not extend beyond few kilometers. Up to few kilometer, yes, but beyond few kilometer, satellites are often into 300, 400, 700, 800. यहाँ पे airspace का कोई meaning ही नहीं है. That is global commons. So ये यहाँ पे applicable नहीं होगा. You can find all of that data visualization. ISRO maintains certain portals that can be another homework. You go and explore these two portals for 5-10 minutes, not more than that. 5 minutes जाओ. There is a portal called Bhuvan portal. That Bhuvan portal has this information gathered by remote sensing satellite of ISRO. You will find thematic maps here. आपको अलग-अलग टाइप के मैप, आपके स्टेट का छोड़ दो, आपको डिस्ट्रिक्ट का भी मिल जाएगा यहाँ पे. बहुत सारे मैप फ्रीली अवेलेबल है. कुछ चीज़ों के लिए आपको लॉगिन वगैरह करना पड़ेगा, जो शायद आपके लिए अलाउड नहीं होगा. You need proper credentials to have login here. But many things are available for free. जैसे I can show you this Bhuvan 3D. This is like Google Map. Google Earth अगर आपने यूज करा होगा, so similarly you have this our own Google Earth version. So we can zoom at a very specific location. I am here somewhere in Maharashtra, I guess, Maharashtra Madhya Pradesh border. And I can keep zooming in and I can look at the very specific land tracts also. And I have that information because of the data collected by remote sensing satellites of ISRO. There is another portal, Bhunidhi portal. Bhunidhi portal will tell you about the soil characteristic. You can find a lot of information about soil profile here. So you can go here also and you can find thematic map, what type of soil we are talking about. Look at a very specific area and we can actually look at what type of parameters we want. All of that filter you can use, and many of that information is available free of cost only. So all of this information is available because we do have remote sensing satellites, right? So any question till now in communication satellites or remote sensing satellites? Is there a sync between the satellites so that they don't collide, or is the launch done in a way that they do not collide? Two things you should know. One thing which I already have told you, that space is really huge, and because of that satellites are quite small compared to the availability of space. तो जो ट्रैफिक, वैसे तो सैटेलाइट का जो ट्रैफिक है वो बढ़ते चले जा रहा है, लो अर्थ ऑर्बिट में पर्टिकुलरली बहुत है, जियो स्टेशनरी ऑर्बिट में बहुत है, एंड जहाँ पे भी ट्रैफिक बहुत होगा वहाँ पे एक्सीडेंट्स होने का प्रोबेबिलिटी बढ़ेगा. So short answer is that yes, there is a finite probability of accidents into space, but that probability is very less, right? The second part of your question, that do we launch? Yes, of course, we have to know about all of the other objects in the space, and based on that information, then we plan our launch. Why would we launch a satellite at a place or in an orbit which is already occupied by some other object and there is a chance of collision? So the second part of your answer is that yes, we do have a good space awareness, presence of other objects into this space, and whenever we are going to plan, we will have to accordingly, we have to make plans so that it does not lead to any type of accident. And the good thing here is that space is so huge that planning this is not actually very difficult, right? ये just हम board पे बना रहे हैं, इसका मतलब ये नहीं है space बहुत huge है. Any other question if you have from these two topics we have discussed till now? हम डिफेंस टेक्नोलॉजी अलग से करीब करीब 1.5 या 2 क्लास करेंगे, ठीक है? तो डिफेंस टेक्नोलॉजी में आई विल स्टार्ट विथ मिसाइल टेक्नोलॉजी एंड विल हैव अ डिटेल्ड डिस्कशन अबाउट बैलिस्टिक मिसाइल, डोंट वरी, ठीक है? अभी हम स्पेस टेक्नोलॉजी डिस्कस कर रहे हैं. एनी अदर क्वेश्चन? यस. सॉरी, मैं सेकेंड पार्ट आपका कैच नहीं कर पाया. पेरिजी पे रिवॉल्यूशन स्पीड अप हो जाता है एंड एपोजी पे कम हो जाता है. क्वेश्चन क्या आपका? हाँ, सैटेलाइट्स के केस में भी होगा, बिल्कुल होगा, इसमें कोई डाउट भी नहीं होना चाहिए. दैट इवन इन केस ऑफ सैटेलाइट्स, व्हेन दे आर एट पेरिजी दे विल स्पीड अप, एंड व्हेनेवर दे आर एट एपोजी देयर स्पीड विल कम डाउन. But the perigee and apogee difference for most of the satellite is very less. So for most of the satellite, even though the orbit is technically elliptical, that ellipse is much more closer to circle. So that is why the difference will not be very huge. And in circular orbit, the speed will be same. Velocity all the time is changing. ये clear होना चाहिए, चाहे वो elliptical हो, circular हो. Velocity तो हर time change हो रहा है. But in circular orbit, speed will be same. जिस speed से आप revolve कर रहे हो, वो same रहेगा. The geostationary orbit में जितने भी satellites हैं, all of them are revolving with same speed. But in case of other orbits, elliptical orbits, speed is also changing and velocity is also changing. Any other question? I haven't come to the significant missions of ISRO. The question is about XPOSat, what XPOSat aims to do. So let me come to that. I will discuss that in next class. Let me first complete the types of satellite. Then we will talk about rockets. And then we will talk about some of the missions in the field of astronomy or for lunar observation or for solar observation, what ISRO is doing. And there I will talk about XPOSat. Okay? I have few questions here asked by UPSC from previous years. There is a question that there are so many communication satellites and so many antennas. Why is it not there a malfunction? कि हर सैटेलाइट कोई और सिग्नल क्यों नहीं रिसीव कर रहा, कोई कुछ और क्यों नहीं कर रहा. अब टू आंसर दैट वी हैव टू गो इनटू कम्युनिकेशन टेक्नोलॉजी, एंड यस वी विल टॉक अबाउट दिस इन नेक्स्ट क्लासेस. And the answer is actually quite simple. It's very similar to when you send a letter to somebody, it reaches to a particular home because you are following a protocol. कि आपने एक प्रॉपर प्रोटोकॉल फॉलो कर रखा है, पूरे कंट्री को आपने पिन कोड में डिवाइड कर रखा है, हर पिन कोड का लोकेशन क्या होगा, उसका नियरेस्ट पोस्ट ऑफिस क्या होगा, ये सारी चीज़ें प्री डिसाइडेड है. सो इवन इन केस ऑफ कम्युनिकेशन, डिस्पाइट हैविंग millions and billions of devices, most of the communication works smoothly because all of the devices which are part of communication system, they follow certain rules and regulations. I will explore this idea in more detail in later classes, not in space technology. This is a topic of communication technology. There were a few questions asked by UPSC. I can show you some of the questions. Look at this question. क्या होगा आंसर? I want more responses from back also. What will be the answer? In which of the following activities Indian remote sensing satellites used? Assessment of crop productivity, yes. Locating groundwater resources, yes. Mineral exploration, yes. Telecommunications? No. Why would we use remote sensing for telecommunication? We do not use, for that we have a group of satellite separately called communication satellite. So fourth is not correct. The reason you got confused is because of fifth option. That can we use remote sensing data for traffic studies? The answer is of course we can. But are we using Indian remote sensing satellite for that? I don't think so. I don't think India is using for traffic studies, for traffic engineering. India is using remote sensing satellite. At least ISRO, कोई हो सकता है कि इसरो का डेटा कलेक्ट करके कोई कुछ कर रहा हो अपने ऑर्गेनाइजेशन यूनिवर्सिटी लेवल पे, बट इसरो लेवल पे आई हैवंट कम अक्रॉस अ स्टडी वेयर वी आर डूइंग ट्रैफिक स्टडीज using remote sensing satellite. But the good thing in this question was that your answer is not dependent upon fifth option. You know that fourth is not correct and you immediately know that answer will be A because first three statements are correct here. Same question in the current pattern. अभी आपने देखा होगा current pattern क्या है? How many of them are applications of Indian remote sensing satellite? And many of the students will mark only 4. They will not mark of course all 5, but many of the students will mark only 4, not only 3. यहाँ पे आउट ऑफ 5 3 है ना सही, ट्रैफिक स्टडीज तो सही नहीं है. सो दिस क्वेश्चन नाउ बिकम्स अ वेरी फैक्चुअल एंड डिफिकल्ट क्वेश्चन. द सेम क्वेश्चन which right now is easy can be eliminated and we can get to the right answer. The same question becomes very difficult because who will try to remember all of the applications, particularly in a very niche application such as traffic studies? That is ISRO doing traffic studies using remote sensing satellite. So as far as I know, it is not doing that. In this question, even that information of telecommunication is more than enough. The answer is A here. What about this question? I want more responses for next question. क्या होगा इसका आंसर? Look at the options. And by the way, both were asked by UPSC. I think this was asked in 2015 or 16. This was asked in 2019, I guess. Land surface temperature of a specific location. I just showed you a map. तो third तो बिल्कुल ही सही है. Greenhouse gas emissions from the rice paddies of a specific location. So greenhouse gases are CO2 or CH4, carbon dioxide or methane or nitrous oxide. And the answer is yes, we can measure that. But chlorophyll ने क्या कर दिया कि उसको measure नहीं कर सकते. Chlorophyll भी after all it is a molecule. Remember we can also measure biological properties. तो जो green cover हम measure करते हैं, that green cover we measure by measuring amount of chlorophyll at a particular location. So even first is true. Presence of, remember, whatever properties objects exhibit, many physical or chemical properties. जैसे chlorophyll का एक जो बहुत simple physical property ये है that presence of chlorophyll leads to green color of leaves. And even that measuring green color allows you to measure the amount of chlorophyll you have. And that is how remote sensing satellites can actually calculate the forest cover in a particular location. So even first is true. Second question में answer D होगा. ये तीनों possible है with the help of remote sensing satellite. I will repeat, remote sensing satellites are very, very sophisticated. Any other question if you have from whatever we have discussed? So I have few homeworks here. I gave you that homework about Earth. Why not 24 hour? Why 23 hour, 56 minute, 4 second? I asked you to explore that Bhuvan portal or Bhunidhi portal. I have one more homework. It's not a homework. I just want you to ponder about what I mentioned earlier, that how light is an information carrier. I want you to think about it. Just think about it. Nothing. Just think about that how light is information carrier and how light exists in various forms. It's not just visible light, but it exists in various forms. I will be talking about the same idea in other classes also. I will see you guys in the next class.